Hello everyone, welcome to yet another session by Scalar, and in this particular session we're going to look into system design complete course. Before we understand what exactly will be covered in this session, please make sure to subscribe to Scalar's channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And if you have any queries, leave a comment down below and we would love to help you out. So now let's understand what are the things which will be covered. We'll start off with relational data modeling, then we'll be looking into horizontal versus vertical scaling. After that, we'll be looking into stateless versus stateful systems, and then look into load balancing in stateful systems. Once that is done, we'll be looking into consistent hashing and also what is caching. After that, we'll be looking into system design interview questions and also mock interviews, which will be the last part of this particular session. So now, without any delays, let's begin with it.
Let's go ahead and see how to apply those tricks in action. The first feature is that user should be able to view and edit his profile, which contains the following information. This gives us a hint that there should be a user entity table. So let's add user entity. It can be a user profile as well. Let's keep it user profile for now. Every entity that you create will have one attribute, which is ID. This will basically be used to uniquely identify a user profile. The other attributes would be coming from the next set of requirements. On top left, a user should have profile photo. On the right side of profile pic, we should also show name and contact information. So let's add these attributes inside a user profile entity. So we'll have a profile pic. Profile pic can be stored in two places. One is in the database itself. If you store the profile pic in the database, the amount of storage that is required to store all the information of the users will be very large. So it's wise to store all the images and video links that are associated with a particular profile into a file store like S3, or we can also store them in a CDN, right? So instead of storing the profile pic, I'll store the URI, which will either correspond to S3 or CDN or maybe any other file store as well. The next information that I would have to store is the name and contact information in form of an email or phone number or both. A user can have multiple skills. So there are two options of adding the skills. The first option is add that as a list object in the same user profile table. So if I am adding this in the form of a list, how that will come up is sample values will be Java, JavaScript, and so on, right? This poses one major problem. The major problem is that if I want to find out all the users who have Java in their skills mentioned, so the problem would be that I would have to write something like a select star from user profile where skills like Java star, which means that this is going to be a scan operation. So if I have multiple rows in my database, then I will end up scanning all the rows. If I have 1 billion rows, I will scan 1 billion rows. So this approach will not scale. The other downside of this particular approach is that I will not be able to auto suggest skills to the user, because that will be again a scan on all the rows that are present in the database. So what we'll do is we'll add one more entity called skills. Now this skill, there are two ways of adding skill, right? Either we can have the skill ID, name and user ID stored directly here. If I do something like this, then again autocomplete will be slow because there will be multiple users and multiple users will be having multiple skills. If you look closely, the two entities, the user profile entity and the skill entity, what is the kind of relationship between these two entities, right? So user can have multiple skills. Similarly, a skill can be having multiple users, right? So it's a many to many kind of a relationship. To model a many to many kind of a relationship, what you should do is you should create a mapping table called user skills. This will, again, all our entities have an ID, so it will start with an ID. We'll also have a user ID here and skill ID. And we can remove the user ID that was there in the skills object. If we read the next set of requirements, it states that we need to keep information about educational institutions and employers. And if you look closely, the attributes over here in the educational institutions and the employers are same. So what I can have is I can create a entity called organization. Inside an organization, I can have an ID field and all the other fields that are there, depicting name, start year, end year, and let's say description. And I will need to have one more type. This type will store information of institution or company. So from the looks of it, or for the given set of features, this table works really well. The challenge over here is that what if I want to add other attributes? Let's say I want to add CGPA in the educational institution and I want to add salary details inside employers. The problem here that comes is that I will have to add CGPA as a one column here and salary also as one more column. Now depending upon whether the type is institution or company, either CGPA will be null or salary will be null. Now it is not a very good idea to enforce application logic in your database. Just by looking at the database, you should be able to figure out that what are the what each column means. So to avoid such kind of a problem and to have a design that is extensible, what we can do is we can split this into two tables. One would be a education and the other one would be a company. Both will have ID, both will have name, it will have start year and it will also have end year. Type is not required because we have already split the table. But this alone will not be able to give me any sense of which user went to this particular university, which users went to this particular company. Now, what is the relationship between user and education and user and company? We would realize that a user can go to multiple companies and he can also go to multiple institutions for completing his education. Similarly, an institution might have multiple students who are studying in it. In a company also there can be many employees. So it's again a many to many kind of a relationship, and we have learned in the example above that whenever we have multiple many to many kind of a relationship, we create mapping entities. So there will be one table for user education and one table for user company. The attributes will be ID, user ID and education ID. Education might not be a better word, or the better word can be institution over here. So we'll have ID, we'll have user ID and we'll have company ID as well. Now if I want to find out all the users who have went to a particular institution, what I'll do is I'll go to user education table and I'll query select start from user education where education ID equal to the institute ID. The next requirement is to have recommendations. Now a particular user can either give recommendations or receive recommendations. Since this is a list, it does not make sense to add this in the attributes of your particular user. It makes sense to have a separate entity. So let's go ahead and create a recommendation entity. We'll have an ID, the person who is given the recommendation, so let's say user ID for that, and it will also have a recipient ID, right? Do I need to create a mapping table in this case? Now a particular recommendation will have just one user ID and it will also have one recipient. That information is actually captured in this particular table, so we don't need a mapping table in case of a recommendation. So if I want to find out all the recommendations that I have, what I'll do is I'll go to recommendation table and I'll select star from recommendations where recipient ID equal to my user ID. So the next requirement is having connections and followers. How connection and follower work is that if A sends a request to B, that means that A will be able to see all the public posts that are made by B. If B accepts that particular connection request, then B will also see all the posts that are made by A. Let's have a design that can model this particular feature set. So we'll have a connection table. Inside this connection table, I'll have an ID, I'll have user 1, user ID 1, and I'll have user ID 2. Whenever a new connection comes in, I'll add that particular row here, and as soon as B accepts the request of A, I'll add one more row. So if I want to find out anybody's followers, all I need to do is select star from connection table where user ID 2 is equal to the given user. So for example, A sent a request to B, so A is a follower of B. So if I want to find out B's follower, I'll need to query the second column, user ID 2. And as soon as it's a bidirectional mapping, I'm adding that particular row as well. So I'll be able to find that out as well. The problem, however, is that I'm taking 2 times the space that I should be taking. So to optimize on space, what I can do is have one Boolean column called is accepted. Now if A and B are a connection, not a follower, that means that A sent a request to B and B accepted that particular request, I can keep the accepted flag as true, otherwise it will be false. Now if I want to find out all the followers of A, if accepted flag is true, then I'll query based on either user ID 1 should be equal to A or user ID 2 should be equal to A. If it is false, then only user ID 2 should be equal to A. The last set of entities that I'm going to talk about is post, comment and like. Let's go ahead and create entities for all of them. So there will be a post entity. Inside this post entity, we'll have an ID. Now, what is the relationship of a post with a user? One user can have multiple posts, whereas the reverse is not true. One post will be written by just one user. So let's add user ID in the post entity table. Whenever you have one-to-many kind of a relationship or many-to-one kind of a relationship, add that attribute of the first entity in the dependent entity. So the first entity over here was user, so we'll have user ID inside post ID, which is the dependent one, and some text to go along with it. Similarly, in comment entity also, we'll have an ID. Comment is made by a user, so comment is dependent on user ID. Comment is also dependent on post, because a comment cannot exist independently of a post. So we'll also have a post ID here. Again, this is an example of a many-to-one kind of a relationship, and it will also have text. Now for likes, we can have 2 tables. One is a post like table. Inside post like, we'll have ID, post ID, again one-to-many kind of a relationship, and a user ID. On a comment like table, we'll have the same attributes, ID, comment ID and user ID. If you notice here, the post ID and comment ID are basically the entity IDs that this like is made on. So for example, in post like, the entity was post. In comment like, the entity was comment. We can club these 2 tables together, similar to we saw in educational and company. Combined table will look something like a like. Like will have an ID, it will have entity ID and entity type. Now this entity type can be of 2 types presently, either post or comment. Finally, we'll also have the user who has liked this particular thing. If I want to add one more entity, let's say a user can have vlogs as well. So what I'll do is I'll create a vlog table over here, and in this type, I'll add type equal to vlog as well. So without even adding one more table, my like table will work. I hope this video gave you some sense of how to design schema for big systems like LinkedIn. This is just a glimpse of what we teach and how we teach at Scalar. Lastly, we'll keep on adding videos on similar topics. Therefore, please subscribe to our channel to get notifications about new videos. Hi, I'm Mohit Yadav and I teach at Scalar. In this video, we are going to talk about Delicious, which was a site that started off as a college project and then scaled to 5 million users. In this video, we are going to learn about vertical scaling, horizontal scaling, and the challenges that comes with it. Now coming to the topic, Delicious. Delicious was a website that offered users to save bookmarks so that they can access it from any computer. The website was started in 2003 by a college student and was later acquired by Yahoo in 2005. This was way back when Chrome was not there and there was no bookmarking service either. By the end of 2008, the website had more than 5 million users and approx 180 million bookmarks saved. This scaled from 1 laptop to 5 million users. We'll start from the day it went live on the creator's laptop. Let's start by understanding what happens when you type Delicious in the browser. Now, browsers do not understand the names. They only understand IP addresses. Hence, we need a way to convert this URL into an IP address. In case of Delicious, DNS will return the IP address of the computer on which it is hosted. Now, since every machine which is connected to internet gets an IP address, and every time we connect to internet, this IP address may change. Therefore, we need to associate a static IP which does not change when you connect to internet again and again. And we need to assign this IP to the computer. To get the whole system up and running, we first need to purchase a domain name called Delicious and then map it to the static IP of this computer. If you look closely, there are two major kinds of requests involved. One is the get or the read request in form of get user bookmarks, and the second one is post or write request in form of add bookmarks. Using the IP address that is returned from the DNS, both this request will go to the same computer. And within the computer, there will be two things running. One is the application server, which will listen to all the requests that are coming to the HTTP port 80. And the second one will be the MySQL server, which will store all the bookmarks that my users are trying to save. So till now, my life is good. I'm running the website for free and I'm using campus internet. My database is set up on my personal computer, so I'm not paying anything for the resources. And I'm making money out of ads. Soon, the website became an instant hit. The user base kept on growing and the challenges also kept on piling up in the same proportion. Every time a new bookmark was created meant that there is a need for extra storage to store this particular bookmark. Now, the best available hardware at that time was around 50 GB of hard disk, 128 MB of RAM. This was basically a Pentium 4 era. To keep up with the demand, he bought better hardware, meaning he bought a better laptop, a better computer. The bottom line is he bought more RAM or more hard disk or maybe multiple cores. But soon, even the best hardware available was not enough to keep up with the growing demand of the business. In fact, most companies of the era focused on upgrading their hardware to solve the growing needs of the business. This form of scaling is basically called as vertical scaling. However, Delicious founder was different. He knew in the longer run his approach will not work. Not only he will be restrained by his system resources, but he might also lose valuable customer data if his laptop crashes. This website is not reachable when his computer is turned off. Hence, this computer was a single point of failure. To overcome the challenges of vertical scaling, his friends suggested him to utilize their own laptops or computers. The idea was to uniformly distribute the incoming requests to available computers. This mode, where we are overcoming the scalability hurdles using multiple servers and computers, is basically called as horizontal scaling. Now, we know that the client talks to the DNS to get IP address corresponding to a particular website. But the question is, the website is now running on multiple server instances. We have, let's say, 4 servers running the Delicious website. Which of the 4 servers available should be stored in the DNS? If I randomly choose any of the available server, all the requests will go to that particular server and that server will eventually die. To fix this, have one machine whose responsibility is to route the traffic to the available instances. This machine will lie between the DNS wall and the servers that I have. And the DNS configuration in the registry, I'll mention the IP address of this special machine and not of any of the instances that I have. Now the question comes, won't this special machine also die if all the requests pass through it? The reason why this special machine will be able to handle higher traffic is because it is only routing the traffic that it is getting to one of the available instances. It is not doing any compute or memory intensive task. And modern day machines can handle up to 1 million requests per second. So using this, we have solved for high number of queries per second on my system. But there is one more problem that still exists. That is single point of failure. Just like any other computer, what if my special server also dies? To solve this, we can have a standby routing server which will not serve or route any request. When my main server goes down, swap the main server with the standby server. But how do I swap? Should I change the IP address in the DNS registry? Doing this will take minutes. Can we do better? Yes, we can. Remember, we assigned a static IP to a special server. The key here is take the static IP and assign it to the passive one. Passive one meaning the standby server. The special server we just spoke about is called load balancer, and we will study more about it in the upcoming videos. Hello, hi and welcome everyone to my new video on system design. I am Mohit Yadav and I teach at Scalar. I've been fortunate enough to work on systems that saw over 10 million concurrent users, and I've also built data pipelines that can crunch around 1 TB of data per day. Having led teams at Nutanix and Hotstar which have built such massively scalable systems, I'm here today to share the same knowledge with you all. In this video, we are going to learn about a very important system design concept called load balancing. To understand how a load balancer works, we first need to look at how a typical request flows through my entire system. A request will start from a client application. This client can be browser, a web app, or maybe a mobile app. This client will call DNS to resolve the domain name that I'm trying to access. For example, if I type delicious.com in the browser, the request will go to the DNS server. DNS server will give the IP address corresponding to delicious.com and it will return it back to the client. Subsequent request will then go to the IP address that is returned by the DNS. This IP address can either correspond to the application server which is capable of catering to that particular request, or it might correspond to a proxy server which will act as a gateway to route requests to the application servers. Since this DNS happens to be the first point of contact for almost every request on internet, this system needs to be very scalable and available. The amount of load that this system takes is immensely huge as compared to any other system in the world. Also, the latency, which is nothing but a measure of time it takes for a system to respond to a particular request, needs to be extremely low. What would be the total latency over here? If I have to calculate the total latency of the system, it would be DNS resolution plus the request time. So request time will be application dependent, but the time it takes for DNS resolution is same for every request on the internet. If this time is high, the overall latency of the system increases. So my goal as an engineer should be latency of the DNS resolution should be extremely low. And to achieve this, we try to cache the DNS mapping at various stages. What are the various stages? We try to cache it at the browser, we try to cache it at the OS, ISPs, and then we also replicate it to DNS servers. There's one more important thing. Now assume that if the DNS servers are placed at only one geographical location, let's say US, and the requests are originating from, let's say, India, it will add lot of latency because India and US are geographically apart from each other. And that's the reason this geographical distance will add to extra latency. Typically, it takes around 200 milliseconds for a request to reach from US to India. So every request which is originating from India and is getting resolved in US will have an inherent lag of 200 milliseconds. It is not a very desirable outcome, right? So to avoid that kind of scenarios, DNS is basically replicated across the globe. And because it is replicated across the globe, updating or changing the IP address on these DNS server is not a very easy task. This change will have to be propagated to the entire world, which might take hours or even days in some cases. I have a wonderful resource in the description that you should refer to understand how a typical DNS works. Also, I would like to pause here and request you guys to please like and share this video and support our free content on system design topics and software engineering in general. Now, coming back to the topic, in the example that we considered, the DNS was just returning one IP address. It will work for most of the websites in the world, but consider this DNS resolution to be of Google or Facebook scale, basically a tech giant which have massive amount of queries, massive amount of user base, and they process billions of queries per second. In those cases, if I just return one single IP address, chances are that all the requests of the client will hit that particular instance, and there is no such instance which would be able to handle traffic of the entire world. So that machine will eventually die. To avoid this, what typically these tech giants do is they deploy multiple IPs on which the client request will resolve to, right? So instead of returning, let's say IP1, they return a list of IP. So IP1, IP2, IP3, IP4, and they send this particular list to the client. Now it is the responsibility of the client to figure out which IP to talk to. Typically, in DNS resolution phase, it tries to follow up something called as a waterfall model. What is a waterfall model? It will try to connect with the first IP. If the connection is successful, it will not connect with IP2, IP3 or IP4. If the first connection itself is successful, it will connect with the first IP. Now, if all the clients will start connecting to the first available IP, that also is not solving the problem. Even though I'm returning a list, but essentially each client is connecting to the first IP that is returned. So if I return the same IP list to every client, I will be gated by a limitation that every client will try to connect to the same IP. What DNS do is, instead of returning the list like this, they return the list in a shuffled order, meaning that it is very much possible that user 1 gets a list like IP1, IP2, IP3 and so on. User 2 gets a slightly different order like IP2, IP1 and IP3. User 3 gets a list like IP3, IP2 and so on. This way, I have successfully distributed the load to my available instances, right? Another way to do traffic routing is to use a geo-based routing strategy. That means people who are residing in India will get an IP address corresponding to India data center. People who are residing in US will get an IP address corresponding to US data center. That also bridges the latency gap. Why? Because if user sitting in India gets a IP address of the data center in US, there will be an inherent lag in resolving the subsequent request. So it makes sense to have a geo-based routing strategy as well. Now we have identified the IP address which will be responsible for answering all my client requests. This could either correspond to a single server or a gateway server which will route traffic to my available servers. If we choose to route the entire traffic to a single computational server, the only way to scale is to run our application on a better hardware. However, if we choose to route traffic via gateway server, we can add more instances as and when required, and adding more instances will help us cater to multiple or higher number of incoming requests. Another important advantage of this approach is that this allows application servers to keep evolving without the need to make DNS changes. Now this DNS changes, we have learned that it might take hours or even days in some cases. So if we have to update the code of my application server, all I need to do is add more application server, let's say AS1, AS2 and AS3, register these application server in the load balancer and deregister the older ones, and I have saved myself from updating the DNS record. If this was the one server case, the IP address of that one server would have changed and I would have to update the DNS mapping as well. Lastly, one very important benefit that we are getting out of having a gateway machine fronting my application server is that this gateway machine also provides a layer of security. How? All the machines that are below the load balancer can typically be in my private network, meaning these instances can typically be disconnected from internet, and whenever they want to be using any data from the internet, it will come only via load balancer. So my load balancer is the wall that connects to the internet, and my application servers just talks to the load balancer. The load balancer also takes care of encrypting and decrypting the message and securing the request via HTTPS. So my load balancer layer can typically be HTTPS, and my application server can implement a HTTP protocol. Now there are two major types of load balancer. One is a hardware load balancer and the second one is a software load balancer. A hardware load balancer is a specialized hardware which takes care of routing the requests that are coming to it. Most likely you end up using a software load balancer which can run on a commodity hardware to route traffic. And this software load balancer is again divided into two types. One is a layer 4 load balancer and the second one is a layer 7 load balancer. This layer 4 and layer 7 translates to the OSI network layer, right? Layer 4, if you remember, is a transport layer, and layer 7 is basically the application layer. In the transport layer, the only thing that we get from the incoming request is the IP information. So we only get the source IP, and based on the source IP and the port in the incoming request, we route the traffic to the available servers. Whereas in the application load balancer, we get much more richer information in form of the headers that are passed in the request, the query params, the path params, and also the HTTP method. But what are the pros and cons of using both, right? In what cases should you use layer 4? If you look closely, in the transport, we only have to rely on source IP and port, and based on this, we route the traffic. So the amount of computation that we are doing in the layer 4 load balancer is less as compared to the computation that we are doing in application, where we are processing the entire request. So in layer 4, it will be much faster to route the request, whereas in layer 7, it will wait for all network packets to arrive before deciding which server should be able to serve my incoming request. But these days, we are having much better hardware, which are drastically reducing the slowness factor of layer 7. However, there is one more distinction why you should still use layer 4 in some cases, because in layer 4 we are exposing only minimal information to the load balancer. We are only exposing the source IP address and nothing else. Hence, layer 4 load balancers are slightly more secure as compared to layer 7, where we could extract the entire information about an incoming request. The last thing that we want to look at is how do we even route traffic from a load balancer to my available application server. Load balancers keep a registry of all the available application server. So it will keep AS1, AS2 and AS3, and it will also maintain the state in which these systems are. So for example, AS1, 2 and 3 are in available state, so it will mark it with green. And if there are other servers which are not in available state, it will mark it with red, and request will not be routed to those servers. But what should be the routing strategy? Our goal is to try and optimize on the resources that we have, and based on the resources, we should route the request. One of the very trivial or the brute force way to route traffic is to send the first request to first server, second to second, and the third request goes to the third server. The fourth request again goes to the first server, fifth request goes to the second server, and sixth request goes to the third server. And we'll keep on doing this circular distribution of requests to all the available servers in my system. This kind of routing strategy is called as a round robin strategy. But as you can see, this is not a best strategy to go for. Why this is not a best strategy? We can see that the application server 2 has twice the RAM, twice the number of cores, and twice the number of disk available as compared to application server 1 and 2. Therefore, it should ideally process more number of requests as compared to the other servers. So what we can typically do is make the routing strategy in such a way that application server 2 gets approximately twice the number of requests as compared to my other available servers. How I can do that? I'll route first request to the first application server. Second request will go to my second application server. Third request will also go to the same server. Fourth goes to application server 3. Fifth goes to 1. 6 and 7 goes to application server 2, and 8 goes to application server 3. That ways, first server gets 2 requests, this gets 4, and the last server will get again 2 requests. Application server 2 is getting 50% load. Application server 1 is getting 25% load. And similarly, application server 3 is also getting 25% of the load. This kind of routing strategy is called weighted round robin. The other routing strategies worth mentioning over here is a least connection routing strategy. This least connection looks at the number of active connections that are there with the application server, and server with least number of active connection will get the next new incoming request. For example, if there are 5 connections to application server 1, 6 connections to application server 2, and let's say 4 connections to application server 3, the next incoming request will go to application server 3 and this number will increase to 5. As soon as this request is processed, the number will again decrement to 4. Here also we have the same problem as in round robin strategy, that we are not accounting for the capacity of the instance. To accommodate that, here also we have a weighted least connection routing strategy where you can assign weights to a particular application server and routing will be done based on that. The last strategy that I'm going to talk about is basically a least response time strategy. In least response time strategy, we look at two parameters. One is the number of connection it has, and the second is the average time it takes to complete a particular request. Considering these two parameters, we decide which server should cater to my next incoming request. Now, all these strategies that we have covered till now work well if every app server is equally well equipped to answer my query. Meaning that if I have a query A, I will get the same response if I send the query A to application server 1, to application server 2 or application server 3. Regardless of where this query is getting processed, I will get the same response. This kind of a system is basically called as a stateless system. The last set of routing strategy that I have not covered in this video is called a hash-based routing strategy. In this hash-based routing strategy, we use the source IP address or the URL and we calculate a hash out of it. We have another video on consistent hashing to explain this routing strategy in depth. So please go ahead and watch the video on consistent hashing to know more about the hash-based routing strategy, right? This typically works on stateful systems. Again, stateful system and stateless systems is something that we are going to cover in the upcoming videos. So please stay tuned for that video as well. Hello, hi, and welcome everyone to my new video on system design. If you are a software engineer, chances are you would have heard about terms like stateless and stateful systems. This video is a beginner's guide to understanding these terms and have practical insights about when and where to use these systems. I'm Mohit Yadav and I teach at Scalar Academy. I've been very fortunate enough to work on systems that saw over 10 million concurrent users and have built data pipelines that can process terabytes of data per day. Now let's get started. Let's say you're building online calculator and you're asked to add two numbers. Do you appreciate that every server in the system is equally well equipped to answer this query? It doesn't really matter which user is asked to do these operations. Every server in the system will yield the exact same result. The reason each server is able to do so is because the servers are not saving any context or state. This makes every server equally favorable to answer that query. Such systems are called stateless systems because they're not storing any state, context or any data in the application server. Now let's consider another example. Let's say we are trying to build a chatbot this time and one user sends a query asking for restaurants that are nearby his location. The chatbot first saves this message in the memory and then responds with a list of restaurants nearby. It then asks the same user to pick one restaurant out of the list. Now the user, let's say, choose third restaurant, and if this request goes to the same application server, it will be able to return relevant information since it has context about the previous chat history. However, if this request goes to some other server, that server will not be able to comprehend the message properly due to the absence of previous conversation history. Therefore, in such systems, the context of the conversation really matters. This context can be decoupled from the application server by simply adding a storage layer to save the messages. Such systems where the context or the state lies within the application server are called stateful systems. Now that we understand what are stateless and stateful systems, let's take a moment to appreciate the pros and cons of each system. We'll start off with stateless systems, which are very easier to scale. The reason is that each server in the stateless system is equally well equipped to handle the request. Thereby, if the load on my system increases, I can just add or remove servers in the system and my entire infrastructure will work just fine. These systems are also resilient to server failures because there is no state which is maintained at the server, and even if one server goes down, there is no
actual loss of data, and the lost server, we can just replace it with a new one and my system as a whole will work as expected. However, most of the systems that you will design will need to store some state in some way or the another. If you want to keep the system stateless, chances are that you will store this data or the state in a storage layer. Now, querying this data will involve a network IO call. This operation will drastically slow down your system performance because you are involving a network IO call. Reading the data from your application server will be slower as compared to doing a network call and fetching the data from the storage layer. Now let's compare this with the stateful systems. Since the context or the state of data required to answer client queries reside within the application, the latency of stateful system is much lower as compared to the stateless ones. However, these systems are not resilient to server failures. If one of the system goes down, the data that was residing in the application goes down with it. Hence, it makes sense to store either the derived data or the data which is actually very short-lived. Because of this, it is also harder to scale, right? It is quite difficult to scale such systems because with the increasing number of requests, we will have to transfer some amount of state from one server to newly added server. This might sound trivial, but in reality, it poses many risks associated with distributed systems. You would have heard somewhere that stateless systems are beautiful and software engineers should always try to design their systems to be stateless. This is true in most of the cases, right? Because we can just add or remove machines and the load of the entire system will be uniformly distributed. However, in some cases, it is essential to store the data locally in the application server as well, especially in cases where the state is very short-lived. I'll give you one very good example. Let's say you're designing a multiplayer game like PUBG. If you store the state of a particular match in a separate storage layer, the latency of the entire system would be huge. Imagine somebody shooting someone in the game. That state is stored in a separate DB and it is propagated to multiple users who are also playing the same game and they are reading from the DB. There will be a lot of lag. Hence, the latency of such systems needs to be very low. So what we do is we store the state of such applications in the application server itself. Also, it is important to note that the state of a PUBG match is very transitive. We will not need this information once the match has ended. Hence, in such cases, stateful systems makes more sense. In nutshell, just like any other system design concept, deciding which system to go for depends upon the use case in hand.
Ever wondered how games like PUBG scales horizontally? We learned that designing a game like PUBG would require us to save the state in the application server itself. We also saw that this state is very short-lived. To understand why, let us see what information we are storing about the game. Every game will have players and each player will have to store their location on the map, their health, weapons and the team information that they are playing in. We need to store this information only till the match is live. Once the match is ended, we can destroy this particular information because it does not make sense. If we store this information in a database, we'll end up wasting a lot of time. Why? Because we'll have to query the database every time a person requests for the match state. And this is an IO call, network IO call, which will waste a lot of time. Hence, it is critical to store this information in the application server itself. Now, in order for a match to work seamlessly, all players of a particular match must be routed to the same application server. Else, they won't be able to find the relevant data for that particular match. To achieve this, what we can do is, we can assign a match ID and ask our client to send this match ID whenever they are making a request. They can send it as a path param, they can send it as a header, they can also send it as a query param. The thing to note here is that the load balancer must ensure routing the traffic based on this match ID. In simple words, if the first request for let's say match ID 2 goes to server 1, all the subsequent requests of same match ID must be routed to server 1 only. Which algorithm can we use to distribute this traffic? Well, in this video, we are going to discuss one such approach. We are also going to look at its pitfall and build intuition for the upcoming video on consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. I have been fortunate enough to work on scale at Hotstar and Nutanix, where I build systems which has massive read and write volumes. One of the reasons behind doing this system design primer series is to impart the knowledge that I have gained over the past 1 decade and help budding software engineers get better at architecting systems. Now coming back to the topic. Remember, our goal was to distribute the load in such a way that all the requests with same match ID must be routed to the same server. Match ID 2, server 1, all subsequent requests of match ID 2 going to server 1. The second point was that the load should be uniformly distributed. Meaning if I have n servers, load on each server must be equal to or must be nearly equal to 1 by n. And finally, I should be able to add or remove instances from the cluster. Why? Because that is the essence of horizontal scaling. I don't want to build an infra where I have constant number of machines. My load on the system can increase or decrease. Depending upon that, the number of servers in my cluster can increase or decrease. The first strategy, if I have to think about the approach, the first strategy that comes to my mind is that I have a match ID, and if I have to route traffic to each of the servers evenly, the basic strategy that comes to my mind is that I can simply take a mod of match ID with the number of servers, which is n. This number will signify which server will process my request. Let's take a few match IDs to see how exactly this is going to happen if we have 3 servers running. Let's say the match ID is 11, 11 mod 3 is 2, 42 mod 3 is 0, so it will be routed to the 0th server. 34 mod 3 is 1, so it will be routed to first server. Similarly, 53 mod 3 is 1, 63 mod 3 is 0, which will be routed to 1 and 0th server respectively. We see that the above approach will satisfy my first 2 goals. Let's dig a little deeper to find out what will happen if we add 1 more server. Now my number of servers or n becomes 4. So let's consider all the examples, all the match IDs that I took in the previous case where n was equal to 3. So now since n is equal to 4, 11 mod 4 will become 3, 42 mod 4 will become 2, 34 mod 4 will again be 2, 53 mod 4 is 1 and 63 mod 4 is 3. Now let's consider the other case where we are removing one instance from the cluster. 11 mod 2, 1, 42 mod 2, 0, 34 mod 2, again 0, and 53 mod 2 is 1, 63 mod 2 is again 1. Now what is happening here? Let's consider the first case. If the match ID is equal to 11, which was getting routed to server 2 when we had 3 servers, will now be routed to server 3 when we add a new instance. Unless we transfer the data which is already residing in server 2 to server 3, our users will not be able to get the match information. And as we can clearly see from the examples that we took above, whenever there is a change in the number of servers, a majority portion of the keys will be distributed to the new servers. And this by no means is an ideal behavior. We need a way to minimize the need of data transfer whenever we decide to add or remove instances. Now before winding up, I would like to give you a home assignment. That's a maths puzzle. The puzzle goes like this. Consider initially there are m servers in the cluster and you can add or remove servers from the clusters. Let's say you do some add or remove operation and the final number now becomes n. This n can be greater than m, meaning that I have added new servers in the cluster, or it can be less than m, which means that I have removed few servers from my cluster.
What you have to do is you have to write an equation using which you can find out the amount of data that will be moved. Write your answers in the comment section and we'll see who gets it right. I hope you all get an idea about basic approach for load balancing in stateful systems. We will look at a better approach, which is consistent hashing, in the upcoming video.
How do you distribute the load evenly in stateful systems? In the last video, we saw one such approach where we used the modulo hashing. The approach works perfectly fine until we decide to add or remove the instances. Whenever we want to add the instances, a majority portion of the keys needs to be rehashed. In this video, we are going to look at a better approach called consistent hashing. I am Mohit Yadav and I teach in Scalar Academy. Now coming back to the topic, let's have a look at the problem statement again. Our problem statement is that we need a distribution scheme that does not directly depend on the number of servers, so that whenever we want to add or remove servers, the number of keys that needs to be relocated is minimized. To understand the solution, let's visualize a circle with marking 0 to a very large number, let's say 10 to the power 18. And we'll call this particular ring or a circle as a consistent hashing ring. Then we'll take two hash functions which will basically generate keys in the range of 0 to 10 to the power 18. Let's call them HS and HC. The HS hash function will be used to mark servers on the consistent hashing ring. The HC hash function can be used to mark partition key or the client ID on the same consistent hashing ring. Now to find out on which server a given key needs to be routed, we need to locate the key on the circle and then move in the counterclockwise direction to find the server. Now there are two main problems with this approach. First, uneven distribution. The server which is located at the max distance in the counterclockwise direction will get the most number of requests. And the second one is the weighted routing, wherein we might have a scenario where one server has twice the number of resources as the other servers. In that case, we need to ensure that the servers with more resources gets more number of requests. To solve for the other problems, what can we do? We can assign many labels to each server. So now instead of having labels A, B, C for three servers that we had, we'll have server labels between A0 to A9, B0 to B9, C0 to C9, all marked in the same circle. Now if server B is twice as powerful as the rest, it could be assigned twice as many labels. As a result, it would end up holding twice as many objects on an average basis. This way we can be sure that the keys are evenly distributed and server with better resources are holding more amount of data. Now let's see what happens when we remove one server. Imagine that server C is now removed. To account for this, we must remove all the labels between C0 to C9 from the circle that we had, the circle which was basically representing the consistent hashing ring. This results in the object keys reassigned to server A and B. Whatever keys were residing in server C will now be reassigned to server B and C respectively. But what happens with the other object keys, the ones that originally belong to A and B? The answer is nothing, absolutely nothing. And that's the beauty of consistent hashing. The absence of CX label does not affect the keys in any way. So removing a server results in the object keys being randomly assigned to the rest of the server, leaving all the other keys untouched. And if you notice closely, all servers are still holding 1 by n amount of data. Earlier also they were holding 1 by n. When they had 3 servers, they were holding 1/3 of the data, and then when we removed one server, every server is holding 50% of the data. Now consistent hashing is used to uniformly distribute the data in stateless systems like Kafka, Cassandra, etc. It's also a very powerful tool that finds its application in the stateful servers, as well as it is a way of implementing sticky sessions in the load balancer.
I hope you got an idea about what consistent hashing is, how it works.
Hi, my name is Anshuman and I'm one of the co-founders at Scalar Academy. If you are new to tech and you have recently heard the term caching and don't know what it means, then this video is for you. I was fortunate to see scale at Facebook. I was fortunate to be part of teams that build products that scale to millions of queries per second and billions of users. I'm here to share some of those learnings with you.
All right, so I'll try to explain caching as simple examples as possible. By the way, there is a bonus problem at the end of this video, so please do stay till the end of the video to look at the solution of that. All right, so let's imagine that you want to make milk tea. One obvious ingredient of milk tea is milk itself. And milk I find in most grocery stores, department stores that are around me. So one obvious way whenever I'm making milk tea is that I go to the department store, fetch milk from here, and then make my milk tea. This to and fro process, by the way, ends up taking a lot of time. However, one thing which strikes me is, by the way, I can buy a refrigerator. I can buy a fridge which stays in my house only, where I can buy few milk cartons at a time and I can store it here. And when I'm making a milk tea now, then as long as there is some milk present in the fridge, I can use it from here. If there is no milk present in the fridge, then I go to the department store and I buy the next set of cartons of milk. So what have I done in the process? I could still have gotten milk from department store. It's the same milk. However, I created this temporary storage, which is close to me, which is much faster for me to be able to store those milk so that I can make my milk tea faster. Plus, then I have more motivation to make milk tea because I have it in my fridge. Very similarly, if you look at the design world, distributed systems world, you always have these systems that are looking for some or the other information, right? So machines talk to each other, they query for information. Imagine you load your Facebook profile page. That profile page would need to show your name, email ID, your friends, etc., etc. So for that, it would need a lot of information. So this machine would then ask for profile information for yours, which would be there in some other machine in the hard disk. And reading from hard disk is slow. If you would have noticed, when you transfer movies, etc., from your friend's laptop, those movies are written to your hard disk, and those hard disk writes are fairly slow. Very similarly, reading from the hard disk is also slow, especially if your data is lying somewhere you don't know where. So you'll have to search through the index to find where this profile information is and then fetch that data from there. However, if the same information was in RAM somehow, which is main memory, then accessing that would be faster. However, I mean, if we're talking about Facebook has so many people, so many profiles, all information cannot reside in RAM. It has to be in the hard disk, which is the same as me going to the department store every single time when I want to make milk tea. However, if I know that there are, let's say, certain profile pages that are fetched very often, that are more likely to be fetched than the other profile pages, then maybe I can create a fridge, a refrigerator, where I can store the information of these pages so that when somebody asks for these pages, then I don't go to the departmental store, which is the hard disk in this case. Maybe I have that information in RAM or a faster memory access. I mean, let's not say RAM, some place where I can find that information faster than actually having to read from the hard disk of a different machine. That process is called caching. Caching is exactly what I did with my refrigerator to department store. It is exactly doing that to reduce the latency of fetching that information in some cases. A cache will never be as big as your total storage. There will always be cases when I run out of milk in my refrigerator or when the information is not present in this fast storage. And that process, by the way, this is caching. And when I find data in my cache, it's called a hit. When I do not find the data because it is not present, therefore I'll have to go to the departmental store or go and read from this hard disk, that is called miss. So whenever you find data in the cache, it's a hit. You don't find it, it's a miss. That is caching. And caching is something, by the way, you encounter on a day-to-day basis. For example, you might have noticed that when you load a website for the first time, it's usually slower. But when you refresh, it loads faster. Sometimes when your internet is not working, you keep refreshing after a while, and eventually the website loads. Your internet doesn't get faster. That's not the reason why it loads. It loads because once, let's say there was an image on the website. Once that image has loaded, that means your browser has now gotten that carton of milk. So it caches that in its own memory. On your browser, on Chrome, it gets cached. So next time when you load the same website with the same image, the browser doesn't go and fetch the entire image from the other website. It only checks if it was the same image. If it was the same image, then it fetches it from its local memory, which means I don't have to go over that slow internet to fetch that image. And therefore, by using caching, I have significantly reduced the latency of fetching that data. That is caching with your browser. Systems within also do caching in various forms. One simple question I have. If you haven't seen my CAP theorem video, please go and see that, because this question is slightly based off that. Imagine you are building a very consistent system. You would want that if you're doing caching, then this cache data is exactly consistent and exactly the same as the data present in your hard disk for whatever entries it has. If you're building a consistent system and you're doing caching there when I ask you to update, how do you go about updating such a system? In the context of the departmental store and milk tea example, let's say that you want your milk tea to always use the latest milk that is present in the department store, or always use the milk that is present in the department store. How do you validate that the milk that you have in fridge as of now is exactly the same milk that is present in department store? How do you do that? There is something called as, if you look at how you would do it, there are only two ways of doing it, right? One is when you tell me that, hey, here is new milk to restock your store with, or here is new data, right? Which is, let's say, and on my profile name, for some reason, my name changes. So whenever there is data pertaining to me that is being updated, it does not go directly to the hard disk. Imagine this is my hard disk or hard disk storage, and here is cache. Whenever this update operation comes, it goes through the cache. So first I check, is this entry present in the cache, which is my name, is my profile cached? If it is cached, then I first update the entry in the cache, and then I update the entry in the hard disk. And only then, when both of them have been updated, only then I return success. This is called write through cache, which means whenever new milk comes to the department store, it goes through me. It goes through my house. I do a verification, and only then I let the milk pass. That is write through cache. Or the other way could be that if the database is aware of where my caching system is, whenever there is a profile update, the database tells cache to throw away whatever information I have regarding my profile, because that is now out of date. And only once invalidation has been done, only this write has been done, invalidation has been done, only then you return success. Or in the context of, again, departmental stores as well as milk, let's say whenever my department stores gets a new kind of milk, they call me up and they say, hey, look, please throw away the milk that you have in your refrigerator. It is old now. We have a newer quality of milk. And that way I make sure I'm always cooking my milk tea with the newest quality of milk that I have in the market. That way I stay consistent. That was all for me for today. I hope again, caching made sense to you. You understood why caching happens in systems.
Hi, my name is Anshuman and I'm one of the co-founders at Scalar Academy. If you're a techie, chances are you would have heard about CAP theorem. Today we would talk about what C, A and P in CAP theorem stand for, why it works the way it does, and what does CAP theorem mean in the modern ecosystem. I was fortunate to see tech at scale at Facebook and was able to design products that served millions of queries per second and billions of users. I'm here to share a few of those learnings with you.
All right, so let's first look at why do we even need to learn CAP theorem. CAP theorem is one of the most basic principles of distributed storage. So if at all you think about building or working on distributed systems in the future, CAP theorem is a must-have, must-know. So that's why you need to learn CAP theorem. Now, before I get into explaining CAP theorem, and I would try to do that with using as simple example as possible, I want to give credit to Kaushik, whose blog I have borrowed a few ideas from. So thank you, Kaushik, for coming up with a very, very innovative example. So let's get to it, right? So to elaborate CAP theorem, I'll take example of a real world example of let's say you. Imagine I am an entrepreneur. I'm looking for ideas and I feel, you know what, like people need reminders. Let's build a service that just stores reminders, right? Which is, I get this very premium number. Imagine I name my company as ABCD and I get this very premium number, which is 1234, 1234. People could just call me on 1234, 1234, and they can tell me what they want to remember. And then when they call me back, I tell them what they wanted to remember, and then things work. It seems to me that this is a great idea. So what I do is I set up this line. I sit in the office. Imagine this is me. Forgive my drawing. Imagine I sit in the office. Every time somebody tells me, let's say I got a call from X, and X says, hey, please remember that I have a flight tomorrow at 9 p.m. I say, great. Next time they call and they ask me, tell me what I wanted you to remember. And then I tell them, you know what, do you have a flight tomorrow at 9 p.m.? And then this seems great. I charge people very nominal amount of money to store this information, and service takes off. Everybody needs this. There's a big market. Everybody starts using it. And then I start to hit the problem. And you'll notice most systems, they start to hit the problem when they hit scale. Then I realize that I'm getting a lot of calls and I'm not enough to address all of those calls myself. So then I start to think, and then I think, sure, let me get my wife also involved. So now this number actually has me and my wife, both of us sit with our diaries where the call gets routed to either one of us, whoever is free. And when I get a call, I just very quickly, if the person is asking me to take a reminder, I just take down that reminder, right? And when the person calls me back, I respond back to the reminder. Great. I have suddenly now doubled my capacity. If I was able to take 1,000 requests in a day before, now I can take 2,000 requests because I have my wife to help me as well. Very soon, I got my first unhappy customer. Mr. X calls me one day and says, hey, can you please remind me when is my flight? And I look through my diary and I realize I don't have an entry corresponding to Mr. X. And I tell Mr. X, hey, look, I don't have an entry corresponding to you. Mr. X seems very disappointed, very angry, and then disconnects the call. Now I start to think, what might have happened? Either Mr. X was delusional, or maybe there was a fault at my end. And then I see that there might have been a problem. It is possible when Mr. X wanted to store their reminder, they might have called my wife. And my wife would have stored this entry that, hey, X wants a reminder for a flight at 7 p.m. tomorrow. However, that entry is not with me because that call never came to me. However, when X wanted to understand when their flight was, they ended up calling me instead of my wife because they don't know. They only know this number, 1234, 1234. And I don't have that entry. And this is why X is very unhappy. This is what is called as consistency problem, data consistency problem, which is an end consumer might have stored some data with me, and when they ask me back, there is no guarantee that they will get the data back, because it depends on where the request comes to. If the request comes to my wife, they'll get their data back. If the request comes to me, they'll not get the data back if my wife's diary has that entry. This is a big problem. If not solved, my company will die. So I start to think, and I come up with a solution. I say, hey, look, here is what we could do. When X calls me to say that, please note down that I have a flight tomorrow at, imagine, 6 p.m. I'll note it down in my diary. I'll also tell my wife to note down this entry, which is also that tomorrow 6 p.m. flight. And only when both of us have written the entry in my diary, in their own diaries, then I return success. Then I tell Mr. X, I have noted down your entry. That way, there is guarantee that both of our diaries, my diary and my wife's diary, they'll have the exact same entries. Consistency of data. They'll have the exact same entries. And great, my consistency problem is solved. Now, when X calls any one of us, we can respond back with the right data points. Things were going great. One day, I again start to face a problem. One day, my wife calls in sick. She's not keeping well, so she's not in the office. What that means is that my wife, for the time being, is gone. For a day is gone. And at that very moment, another gentleman, Y, calls me and tells me to note down an entry. I say, okay, sure, what's your entry? And they tell me, you know what, I have a flight tomorrow at 3 p.m. I say, great, let me note it down. Let me, by the way, also go and tell my wife to note it down. Oh, by the way, my wife is not here. She can't note it down. And therefore, I'll have to tell Y that, hey, I can't note down your request. Your request actually has failed, which means for the entire day, I can't take in any new requests. That is a availability problem, which is my system is not available to take all kind of write requests. In the case of software systems, for example, like Facebook, you could think of Facebook saying that for an entire day or for an hour or for a few minutes, you can't make any new posts or you can't post any new photos on Facebook. That is an availability problem. So again, I'm very stressed. What do? I don't want my business to fail. So I think and I come up with another solution. I say, you know what? When my wife is not here, so I have my diary. And imagine my wife is not here. So I have written a bunch of entries. This new day comes. Whatever entries I get, Mr. X says to note down something, I'll note it down. When Mr. Y says to note down something, I'll note it down. And when my wife returns back, because I want both of our diaries to be identical, I tell her, look, you'll not take up any phone calls till you have noted down all of the additional entries that I made in the previous day. Or if she was gone for last 2 days, then in the previous 2 days. So you first note down all of the additional entries and then you start taking calls. And then my problem is solved. Now, because if X calls me and says that, please note down that I have a flight tomorrow at 8 p.m. Even if my wife is not in the office, I can still note down the entry. And therefore, I'm still available. Since my wife will come back and she will actually catch up with whatever new entries are there in my diaries before answering any phone call. So we're also consistent, which is great. Things are going super good. And then comes another problem. One day, me and my wife, we both have fight and we stop talking to each other. So imagine I get a phone call, X says, hey, look, please note down, I have a flight tomorrow at 9 p.m. I can't note it down because I'm not able to talk to my wife. And if I note it down, then and tell X that, hey, look, I have noted down your entry, then my system becomes inconsistent, right? Because my diary has now different entries, my wife has different entries, and she's still taking calls. So when this network partition happens, where I'm not able to talk to my wife or other systems, then I have to make a choice. Do I want to stay consistent or do I want to stay available? If I want to stay consistent, then if Mr. X calls me and says, please note down the entry, I will have to say, sorry, I can't. My system is down. It's not accepting any new write requests. If I want to stay available, then I can take down the entry, but then I become inconsistent. So if I choose consistency, then I become unavailable. If I choose availability, then I become inconsistent. And that is exactly the CAPS theorem. CAPS theorem says that if you have consistency, if you have availability, and if you have partition tolerance, then at a time you can only guarantee 2 out of these. You can't promise all 3 at the same time. which means when this network partition happens, I would have to choose between consistency and availability. I can't have both. That's the gap theorem. Now I have two bonuses to add here. Most systems that are available and partition tolerant, which is called AP, A for availability, P for partitioning, C for consistency, right? Most systems that are AP can still make sure that they become eventually consistent. What does that mean? That means eventually my and my wife's diary, they have same entries. How do I make sure of that? Whenever we start talking again, we can exchange notes. Or maybe just imagine that there is a clerk here that I've hired who just takes up all of the new entries in the last 1 hour, tells me what those entries were, so I take those down. Also, by the way, ask me what were the entries that I made in the last 1 hour, goes back to my wife and tells, here are the new entries that were made in the last 1 hour. So there might be periods in between that I was inconsistent, but eventually we become consistent. So that is eventually consistency. There is one more extension to CAP theorem that was done very recently, actually not very recently, about 10 years back, which is called as PACELC theorem. And what this theorem states is that, hey, look, when network partition happens, when my systems can't talk to each other, then sure, you have to choose between availability or consistency. You can't have both. However, there are going to be cases when my systems can talk to each other, which means there is no network partition, which is else. So else, I have to choose between latency or consistency. I can't have both. If you notice, when I made this decision that to stay consistent, I will make sure that on every single call, I will make sure my wife also notes down the entry, and only then I return success. Then I'm actually waiting for my wife to note down that entry. My wife could be doing something else at that time. My wife could be answering some other call. And in that case, the entire request might end up taking a lot of time. So the latency could become high because I want consistency. However, if I was willing to let go of consistency, which is I wanted to say that, hey, look, I'll just note it down, and maybe my wife could probably catch up later on, then latency could stay really low. So then you would actually have a balance between latency and consistency when there is no network partition. So that's what PACELC theorem is, which is just an extension to the CAP theorem, because CAP theorem does not talk about latency. I hope that made sense to you, and I hope that was helpful. This CAP theorem is one of the most basic and one of the most useful theorems you'll come across when designing distributed systems. I'll keep doing more videos like this. If you like this video, please like the current video and subscribe to the channel. Thank you. Thank you so much.
Hello everyone, welcome to this session on system design. Primarily objective of this round is to help you guys, tell you about what kind of questions you can expect in system design round, and more importantly, how do you answer in a particular system design round. So we'll take one example, we'll discuss one framework around what should be the ideal framework around discussing such questions. All right then, let's get started. So the agenda, first, let me give you a brief about why, these system design topics are important. They have importance in two areas, right? One is your ongoing job, and the other one is the interviews. So whenever, specifically, it makes sense for people who have higher experience, right? People who are coming from, let's say, 2-3 years of experience, they are expected to have some knowledge about system design, right? So system design encompasses two main components. One is the low-level design, wherein you'll be expected to either write the schema or maybe design the APIs or maybe design the class, like what are classes and interfaces, how would you design that particular code. And the other one is having a broader perspective of how different components are going to behave. So typically, to have you'll basically get around 1 hour or maybe some more time to discuss a particular system in detail during your interviews. So it's best to follow this particular framework. I have followed this particular framework for Facebook, and I was able to crack Facebook with this particular framework. And whenever you apply, also your recruiter will also tell you about the same framework that I'm going to be telling you. So without wasting more time, let me just introduce the framework to you guys, and then maybe if you have any questions, you can type it down in the comment section. I'll read the questions from there, right? So the framework has 5 steps. It's a 5-step framework.
you always start with gather requirements, right? So your first step should be to gather or ask clarifying questions about the requirements. Most of the time, I'll give you side by side whenever I'm giving you the framework, I'll also give you one example and correlate how, if for this particular question, what should be the ideal answer or ideal output. So let's suppose I'm asked to design a URL shortener, right? Let's suppose I appear for a Facebook interview and my interviewer asks me that, hey, you need to design a URL shortener. Now, this by itself will basically give you some hints about how you should typically approach the problem. Even if the problem is 100% clear to you, you must ask some clarifying questions. Most of the time, the problem will be vague enough that you will have to ask, clarifying questions. But even if the problem is crisp, clear, just reiterate the problem in the same, in your words, so that you and the interviewer are on the same page, right? So gather requirement step will basically, for example, if I'm asked to build a URL shortener, for me, the requirements can be, do I need to add personalization, or do I need to add support for analytics? Do I need to support things like expiry of a particular long URL? If somebody uses my service and I give a particular short response, for how long should I persist that particular short URL to long URL mapping? That is also a business statement, and that will dictate how my design will look like. So it is important to ask such clarifying questions in the gather requirement phase. Now, I hope the first point is clear to everyone. Let's move to the second point, which is once you've got an idea or got a sense of the requirements that you'll be building out, just write all those requirements down on a piece of paper or Google Doc or anywhere, right? If you're doing it on a whiteboard, you write the requirements, freeze the requirements on the whiteboard. It is important to note here that do not spend lot of your time on this particular part, gather requirements part, maybe 1 or maximum 2-3 minutes on this particular aspect, right? After that, you need to spend time on estimating the scale. Now, there are multiple subsections to estimating scale. The sense or the idea that I'm trying to get out of estimate scale is, now this is also one more area, just like gather requirements, your interviewer will work with you to basically give you the requirements. You'll give certain assumptions, the interviewer will say yes or no, right? Or maybe you can ask question to the interviewer and he'll give you the answer for that. For estimate scale also, for example, if you don't know what your starting point is, just ask how many daily active users are going to be there. So for example, I was asked to design a URL shortener. I asked my interviewer how many users are going to use it, or how many daily active users are going to use it. So let's suppose my interviewer said that there will be 1 million users, which I can expect to use my service. So in the estimation scale step, what I need to do is I need to convert this 1 million daily active users to find out how much storage is going to be required to convert these 1 million daily active users. Now, my interviewer also tells me, or I tell him that, hey, I am assuming that 90% of my users will just read the data and only 10% of the users will write the data, right? Now, this is one assumption that I'm making. I'll express this particular assumption to my interviewer, and based on whether he says it's a fair assumption or not, I'll change these numbers. But for our system, let's suppose these are the numbers. So 10% right means that 1 million into 10%, which means around 100k users are going to write something are going to generate data on a daily basis. Now, what is the data that these guys are generating? These guys will give me the big URL. I'll have to somehow do some transformational magic here and return a small URL in return. This big URL can be, let's say, 100 characters, and this short URL can be 10 characters, right? So this is the kind of transformation that I need to do. Let's suppose to store the entire record, I can store it using 1 KB of space. So what is the daily space that I'm going to need? The bare minimum daily space that I'm going to need for my system? It will be 1 KB of data for one record, because one record is taking 1 KB, multiplied it by the number of users that I'm getting who are generating the data on my website. How many such users are there? There are 100K. So this is 10 to the power 5, which is something around 10 to the power 5, 3 MB, around 100 MB of data, right? This is on a daily basis. So Bhagyarana says that it should be 1 million into 10 to the power, into 1 KB. It won't be 1 million. The reason it will not be 1 million is because only 10% of my users are generating that particular data. Not all of them are generating the data. The people who are generating the data, that means they're using my service to shorten a particular URL. Only those users will be considered. Hence, I've taken 100K users, right? Which basically means that I'll be storing around 100 MB of generating around 100 MB of data. And if I have to calculate for a particular year, one particular year, then it will be 365. I'll have to multiply it by 365, which would be around 3.65 or 36.5 GB of data. Right? On a yearly basis, my service is going to be producing this. Why am I not taking the read into consideration while storage? Because I'm only storing whenever a person is requesting a shorter URL for a long URL that I've got, only then I have to store that particular URL. What happens when a person wants to read that particular URL to a big URL? If a request comes for reading this particular URL, I'll go to the storage, I'll read whatever is the corresponding big URL, and I'll return it back to the user. So in that, I don't need any storage, right? So the second step, which was estimating the scale, the most important thing is to estimate how much storage you are going to require. Because this number, this 35 or 36 GB number that I've got here, tells me that only one instance can basically hold this particular data. The entire data for 1 year can fit into one machine itself. If this would have been around 1 TB or more than 1 TB, I would have required multiple machines to store that particular data, and hence I would require more. Since I require more machines, I would require some sort of a sharding, right? But in our case, we've seen that it is just around 36 GB of data. One instance can handle it. There are still problems. We'll come to what are the problems. But I'm just giving you what are the numbers that we need to take care of, right? So coming back to our important parameters for estimating scale. First was the storage. The other important parameter is to identify the TPS of your system. That means how many requests are you getting per second. That includes of write TPS. Write TPS would be that a person is giving you a long URL and you need to return a short URL for that. A read request in this scenario would be a person is giving a short URL and you have to return a long URL. So you need to find out the TPS of every system. TPS, the full form of TPS is throughput per second. People call it QPS as well. QPS is query per second. Some people call it reads per second, writes per second, and bifurcating it. Basically, the crux is that you need to find out what would be the number of requests for reads, what would be the number of requests for writes. Because if these numbers are also very high, let's suppose you are getting 1 million reads per second. That means that you need to have some sort of a caching enabled. You need to have some replication enabled, because one server will not be able to cater to 1 million IO calls. So there is a network bandwidth limitation as well. This is the reason why you should estimate the TPS as well. I hope that makes sense. Now let's move to the third important part, which is once you have estimated the scale, then you look for what are your design goals. What should you solve for in this particular problem? Design goals, if I have to just give you an idea about what typical design goals are. If you have not heard about CAP theorem, just go to our YouTube. There's a playlist on system design. Go to that playlist and see all the primer content. So there's a theorem called CAP theorem, which states that either in a scenario of a partition tolerance, you can only have either consistency or availability if you're taking the partition tolerance into account. So one of the design goals is to identify whether you're designing for a very consistent heavy system or are you okay with eventual consistency and you prefer availability on that particular scenario? So identifying that is one part. Let's talk about the case that we are building. Do we need at most consistency? If I just have to explain consistency in 2 lines, consistency states that if there are 2 data nodes, let's say there is data node 1 and data node 2. Now, if the value of x is, let's say initially x is 5 in both the cases, then I get a write request which basically updates the value of x to 15. And let's say that particular value was written in data node 1. Now, if I fire a read request, depending upon whether it is going to data node 1 or data node 2, 15 or 5 would be returned. In a strongly consistent system, we'll get 15 as the response. In a weakly or in an eventually consistent system, I may get 15 or 5 both, depending upon whatever is the output. So do I need at most, do I require my system that every node, every data node in my system should have the exact same data? The answer is no, because there are very less updates. I'm just adding whenever I generate a big URL. Once it is copied, once it is added into the database, I'm not modifying it. So either the date value will not be there, or if the value is there, it will be same for all the cases. Right? So I don't need consistency. I can live with eventual consistency. Do I need availability? I don't want, if I've generated a particular URL and I've sent it to millions of people. Let's say it was a Google I/O event, or maybe Donald Trump, or maybe Modi ji giving some speech, and to that link to that particular speech, I have let's say shortened it using my service and I've sent it to multiple places. If those people are not able to reliably see the output or reliably able to access my service, in that case, it will be a massive hit on my website and the credibility of my website. Hence, I cannot let go of the availability part, right? So design goals mein, you need to identify this, that whether you need consistency or should you prefer availability. In case of a partition tolerance, we've seen, we most of the cases, you would require some sort of a partition, right? So that was my third part. Having the design goals. You first identify what trade-off you will have, consistency versus availability trade-off, and the second trade-off is between latency, right? What is the kind of latency are you looking at? So let me just write it down and then I'll explain what latency means. Now, different systems would have different requirements for having latency. For example, the URL shortener one that I've given you, if I give you, if somebody types a shortened URL into the browser and then tries to access the bigger, URL, if that particular takes time, if the lookup itself takes a lot of time, it will not be a very good indicator on the website, because let's suppose it was basically a URL representing one particular event. Now, it's not a very good customer experience if they're just spending on the resolution time, right? I'm further slowing down the service of the end provider. So since I don't want that, I need the system to be very low latency driven, right? But it is not like people might think that we would need such kind of latencies in every scenario, but that is not a case, right? All the batch systems, for example, if you build, that can have higher latency. When you sign up for Netflix, for example, it asks you that, hey, what are your choices? Do you like to, select some movies that you like watching? And based on that, they give you some recommendation on the once you open the Netflix homepage. Now, the same thing happens with Spotify as well. For those systems, the latency can be high. Like it is still bounded by some seconds, maybe 10 or 15 seconds, but it's higher as compared to, just signing up on Netflix. You enter your email, you enter your password, and you're done. So depending upon the system you are building, you might have varying level of latency. And by varying level of latency, you can decide whether you want to build a system which is a batch system, or do you need a real-time processing system. So I'm taking a very simple example, but I hope you are getting at the point that using the same methodology, you can solve really complex problems as well.
By the way, if you are interested in a very complex problem also, we take master classes. Those are free, completely free. You can join us at in one of the master classes. It's a slightly longer format, hence we get to pick up slightly difficult topics than designing a a URL shortener. So if you are interested in let's say building YouTube ingestion pipeline, that is going to happen tomorrow, right? So you can attend that. I'll be taking a YouTube, how does YouTube delivers its data to millions of customers which are globally distributed. I'll take a session on that on Sunday, so you can attend such kind of sessions. That will have a little more complexity as compared to what we are doing right now. This is the link for the masterclass. So anyone who's interested can attend the masterclass on Sunday. It happens on Sunday 5 p.m. Right? There will be a couple of more master classes which are listed. We take master classes on data structures as well. We take master classes on the system design aspects as well. Cool. So coming back to our original problem, coming back to our original framework. So we have discussed the design goals part of it. The next part of it is so before I tell you about the next part, how do you typically build a system, right? You don't, for example, if you have to run a marathon, you don't directly participate in a marathon. You maybe start to walk for a longer distance, and then maybe you start building up stamina, then you run 5 kilometers, then 10 kilometers, and then maybe you run for a 42-kilometer marathon. Similarly, in a system design concept as well, whenever you're designing a particular system, assume that everything, right from your storage requirements, your TPS requirements that we have identified in the step 2, all those requirements can fit in a single machine. Why do we make this particular assumption? This assumption is made because if you keep everything in a single box, that means you can have any kind of flexibility. The only thing that is reduced now is all the problem is or all the data can fit into single machine, which means you can use RDS. There's no need of optimization or anything like that. We'll identify what are the bottlenecks and we'll iteratively build on top of it. We'll iteratively remove all the bottlenecks. So the last or the fourth point is basically you design for a single server. Whenever you're designing for a single server, you need to take care of DB schema. This is our DB based DB schema. Don't directly jump to any NoSQL system. It's a major red flag, right? So even if you have worked thoroughly on Cassandra or maybe Redis or maybe any other database, it's a red flag if you directly jump to that particular database. Always start with RDBMS based schema, right? Once you have started with RDBMS based schema, then you move to designing the APIs and writing the business logic as well, right? Now, if I have to do the same thing for design schema and do all those things for our case as well, so let's do that here. So for the let's start with the API, right? What are the APIs that needs to be there? There'll have to be a post API, which would something be like shorten, and in the body I can get the URL and expiry, right? This would be the body. This is one API. The second API is basically a get API. Get is nothing but slash whatever is the short URL, and then there's no body in get, and you give long URL as the response. So these are the two main APIs that needs to be there. I won't spend much time into how we design that. That's a separate topic in itself. How do you design REST APIs? What makes URL RESTful? What does not make a URL RESTful? All those things we'll consider later. Like that's a topic of discussion for a different session. I won't go into that. Then you have to design the schema for this particular problem. The schema for this particular problem is a simplistic one table schema. You can have something like a short URL, you can have a long URL, and you can have validity, which user generated this, and maybe created at, and maybe some other 3-4 other tables. But the main columns are short URL and the long URL and the validity. Right? These three columns are the main columns. Using these three columns, I can answer both the APIs that I have listed out. Right now, I have done just a quick checklist. I've made the DB schema. I've made the APIs. The only thing remaining is using the what should be the business logic. Now, if you think about the business logic, this problem can be solved in variety of ways, right? One of the way to solve this particular problem is to have one ID field here, right? This ID can be an integer, and whenever you store something inside a database, that ID will get automatically generated, incremented to be precise. So it started with 1, 2, 3, 4, 5, whatever is the number, that is the shortened URL. And that will not go beyond, we are generating only 100K users per day and some 36 GB of data per day, which means that your shortened URL will not go beyond a certain limit, right? It will not go beyond 6 digits or 7 digits or maybe 8 digits, right? Whatever big URL you are getting, you just return the ID and that will be the shortened URL. But that is not a good approach, right? I hope everyone can realize that it will not be a good approach if you just rely on the database auto-generated ID. Why that won't be a good approach? Because that's easily guessable. So if I have, for example, I used your API and I used your API to generate a small URL, and then what I did was I just you returned me 54. That is telling me that hey, there are 53 other entries already present in the database as well. So I can just query using 52, 53 and find out who all are using your services. So it's easily guessable. So that's out of picture. The second approach. So first approach was basically relying on auto-generated ID, right? The second approach, which I think Rahul has also pointed out, is around using the UUID or maybe using the hash function like MD5 or SHA-256 and things like that. By default, we cannot use UUID. Why? It's a 32-bit character. Essentially, we don't require anything like this. Why? Because it is generating 32 bits of characters. I don't need 32 bits. MD5 also is 32 bits. SHA-256 is 256 bits. I don't require these many characters. Why? So let's look at how many numbers I can generate with one single character, or how many URLs can I store with one single character. With one single character, I have 26 choices of alphabets plus 10 digits, 0 to 9, 10 digits. So around 36 choices I have only with alphanumeric characters if I use it for shortened URL. If I also include the casing, I'll also introduce another 26 characters, which makes the total tally to 62. So with a single character, I can represent 62 big URLs. So let's suppose my big URL was this. I transformed it and I said that, hey, I will represent this big URL with A, and I'll store this particular mapping to in the database, right? Now, how many URLs can I store using two characters then? The first 62, the first character can represent 62. The other character can also represent 62, right? So it will be 62 into 62, which is equal to 62 raised to the power 2. How many for with 3? 62 raised to the power 3, and so on. How many with n characters? 62 raised to the power n. So even if I have 5, right, 62 raised to the power 5 is I think somewhere in millions or billions, which will do my job. In case I need more, I can add one more, 62 raised to the power 6 probably, and I will get my response. I will get my final. So Shivans Dubey says it will be 62 into 61. No, I can use A and capital A again. So for the other character also, I have the exact same repetitions can be there. Anyways, in either of the cases, 61 or 62, that really doesn't matter. What I was hinting or what I was approaching from this particular discussion was that there'll be exponential number of combinations that I can create with a limited set of characters. So I have solved one part of the problem. right? The part of problem that which all characters or what should be my business strategy to come up with to represent million or a billion long URLs. That I have really solved. I've solved for that. What I've not solved for is the guessability factor, meaning that if I have A, if I return someone AA or maybe a AB, right? Let's suppose I return AB. This really tells me that there has to be a URL generated with AA. So what can I do to remove this guessability factor? Any thoughts on that? How do I remove the guessability? So what I can do is I can generate multiple messages with, or I can pre-compute all the numbers, right? I can pre-compute everything, and then I pick up the first million, and then push it into a set, a hash set. A hash set will just randomize it, and then I can just iterate on the key set. Once I have accessed a particular code, I can save it in the database. That will basically ensure that that will basically ensure that guessability factor is removed and it is scalable as well. So that was my point number 4. How do you design system that can work in a single machine, right? Design for a single system or for a single server. Now, to add scalability factor, we need to, what can be the bottlenecks? That one server is not enough to cater to my high read TPS. In that case, what can I do? I can have multiple servers who are running this piece of logic, and each server is responsible for, each server is basically responsible for generating its own version of code, right? So I can say, let's suppose I have running 26 servers, or let's suppose I'm running only 3 servers, server 1, server 2, and server 3. I give 1 million pre-generated coupons for this one, 1 million to this, and 1 million to this, right? So as and when I'm adding new servers, I'm giving this 1 million set of pre-generated codes that can be used by that particular server. While assigning this 1 million coupon codes, I can ensure that there is no collision. Once these codes are residing in the memory of the server, I'm not introducing any new latency, and I'm ensuring that the data, I have designed a low latency system that can scale to millions of users as well, right? So that was the basic idea, right? You go for first 4 steps. You gather the requirements, you estimate the scale, you find out what are the design choices or the design trade-offs that you need to make. Once you've identified that, the next step is to basically design your system that can work on a single system. That will involve writing some DB schema. That will also involve writing APIs and also finding what is the core business logic that we should support, right? Once that is done, then is scale for the numbers that you have identified in this step. Estimate, scale step. How do you basically scale for whatever you have decided? Once you have discussed all the approaches and all the problems, then you go back to the gather requirements, the MVP stage. In the MVP building stage, you have written some requirements. Just go through each requirements one by one and validate that whatever you've written is working fine, and all the features that you've discussed earlier are taken care of, right? So this was the basic idea. Now let's jump into the question, and I will stop the screen share. Yeah, so he was asking that while I was estimating the scale, won't I consider the read ones as well? Because there were number of the number of users who are doing the read and the number of users who are doing the write operations are different. Hence, I think the question came that read ones should also be stored. I think that is not required, because whenever you have to write something to a database, only that amounts for the storage. Read once you'll consider while calculating the TPS or throughput on your system. Then you'll basically have to consider the read request as well. His another question was that expiry of URL, would it be 24 hours, 1 week, availability must? So that's a valid question, which you should definitely ask when you're appearing for interviews. I didn't clarify while I was designing it, but I had taken the expiry from the client itself. Whoever is generating the URL can typically tell me that when is it that he wants this particular URL to expire. By default, I can have some, keep the link open for maybe years, but you should have a fixed expiry to all the, whatever you're adding in the database. And this is a very key concept if you think closely about it. Expiry can save you from adding or having to add multiple, shards as well. Why? Because if you don't have expiry, your data will keep on growing, right? It will go on a linear scale or exponential scale depending upon how people are interacting with your service. But if you truncate older data, that means your same single database instance can serve the request as well. So that is actually very important, that you clarify with your interviewer that what is his expectation out of the expiry. Most likely, if he asks you to design a URL shorter, even expiry will not be a explicit ask, right? This is something that you as an interviewee should have clarity on. You should ask that particular question, right? Cool. Batch versus stream, when to use, right? That's a very interesting question. I think it actually depends on your use case, right? For example, in some cases, batch processing does make sense. I'll give you one example, right? For example, ClickBuzz. Let's suppose we have a website like ClickBuzz. Now, ClickBuzz have started, let's say, one game wherein people can play or people can chat live during or comment on anything while the match is going on. After the match is over, they'll find whatever or whoever has the maximum number of like on a particular comment, they'll reward that particular user. Now, in this case, either you have both options. Either you can stream all the comments that are coming and then have an aggregate on number of likes each comment is getting. Or since it's a one-off activity after, which is supposed to happen just after the match, you can also use a batching system here. I would use a batching system here solely because it's a activity which will happen only after the match, right? If you see IRCTC website, that goes down after 11:30 p.m. every day. That is because they want to reconcile everything. It's a batch process. The salaries, for example, are a batch process. Where I would need a stream, I think a stream processing engine would make sense. For example, if I want to do some cloud deployment and I want to check whether in real time, are there any security anomalies in my cloud deployment, right? Or for example, any kind of an audit that I want to maintain, right? For example, if somebody launches a EC2 instance and he has attached a public IP to that particular instance, that is an opening into my VPC cloud, which is a security threat. And ideally, I would want to catch it in real time. So over there, I would go for the stream processing engine because I want to have a live action defined for every outcome that is happening, right? Okay, I think that's a very good question. His question was, when I was defining the schema, right? When I was defining the schema for my URL shortener, I didn't add ID. ID I added later only when I was, going to the business aspect of it. But a quick yes or no in your mind, just keep a yes or no in your mind. Do you think a primary key is required in this case? Let's talk about yes and its implication of having a external ID. If I have an ID, internally, all the MySQL or RDBMS system, what they do is they sort the data physically based on ID. So ID 1 will be placed closer to 2, will be placed closer to next to 3, will be placed next to 4, and so on. So this helps in fast retrieval of data because they are able to look up for that particular key in a very fast manner. Now, my primary lookups, I have seen this many people doing this, that they just add ID for the heck of it. There is no real use case of it, right? For me, my ID is most of the time my requests are going to be short URL. Given a short URL, what is the end long URL? That is going to be the reads. To optimize for that, I'll keep the short ID as my primary key. It is unique, right? And I want the data to be fetched using that. Hence, having an explicit auto incremental or any kind of other ID is not required. Just having a short URL will serve my purpose. So if you want to go deeper into it, just read about locality of reference. It's a very important concept, primarily used in DBMS systems. So you can typically go ahead and look into that. UUID, Hashbase, and all those systems does not work solely because they generate 32-bit numbers. And let's suppose I skim the last 5 or last 6 also, then also there'll be many chances of collisions. So dealing into those areas will just be problematic. Pseudo random number generators. So for anything that you're doing with randomness, right, either the range has to be a lot, meaning, for example, for 32-bit number MD5, that is basically a good enough hack to generate a 32-bit unique number, or I can go with UID and generate a random number. But if my range is limited, now let's just to give you an example, let's say I have only two numbers, 0 and 1, and I ask you to generate a random number between 0 and 1. You generated 0. Let's suppose the first number that you generated was 0. I again ask you to generate a pseudo random number. Let's suppose again you generated 0. And again I ask you, and again 0 was generated. Right now you just have one number remaining, and there are many chances of collisions. There are 50% chance of that you generate the number which was already generated before. Now let's increase the range of your numbers. Now you have 0, 1, 2, 3, 4 numbers, right? Let's suppose 0, 1, 2, these 3 numbers are already generated. The probability of generating a new random number which has not been used earlier is just 0.25. 75% chances are there that you'll generate the number which is already generated. So as you keep on exhausting the available resources, the operation which was already O1 operation is basically tending to ON, right? You can take n chances to generate that particular number. If you have 100 numbers, the probability of one number getting picked up is 1 by n. So if you have out of the first 100 numbers, you've filled up 99, the probability of generating the number which is not used randomly is very, very less, right? So it's 1 by 100. So you have to take 100 tries, then find out that particular number in a best case, in a probabilistic kind of a case scenario. So that's not a very good way to find it out randomly. Randomness helps you in some cases, but randomness is not a good enough criteria. So you can search for this particular problem. It's a very famous problem asked in interviews as well, asked in coding interviews as well, that if you have one array and you want to pick up random indexes in an equal probability. So let's suppose you have numbers from 1, 2, 3, 4, 5, 6. Out of these 6 numbers, you want to give equal probability to each number and find out and generate a random number out in this. How would you do that, right? The standard way of doing that is you always generate a number from, since you had 6 places, you generate a random number from 0 to 5. Whatever is the index, let's say 3 is picked, you swap 3 with the last element and you decrement the range. Earlier, the range of finding out the random number was 0 to 5. For the next iteration, it will be 0 to 4. For the next iteration, it will be 0 to 3, and so on. And you keep on swapping the index of element which is getting picked with the last value. How is the server assigned a set of million records out of all the possible records? I think I have discussed this problem very briefly. You can generate all the sequences, first million sequences, then second million sequences, and third million sequences. Whatever is the sequence that you've generated, put it in the hash set. Hash set will automatically rearrange the keys, right? It is not a list typically keeps everything in order. If you put it in a hash set kind of a data structure, it will automatically jumble up the records that you're getting, and that will basically ensure that you're getting a random ID every time. Batch processing would be Amazon order, salary, stock market, yes. Stream processing, live sentiment analysis. Sentiment analysis also can be done using batch processing. Might not be it actually makes sense if you want to triage or maybe alert or mark as misinformation on Twitter or Facebook these days. So yes, you can use sentiment analysis, which can be assumed. Let's take this question. He says, if we are pre-assigning the short keys, won't it be time taking for searching available key to assign, as if we are trying to create on a particular second? No. So let me explain this process. Let's suppose these are my available slots. Now, what I need to do is, whenever a request comes, I need to pick one number out of it randomly, right? And assign it to the incoming request. This is stored in memory. In memory meaning this is stored on the same server on which my application server are running, right? So let's suppose the first request comes and I generate the random number. The random number which was generated between 0 to 6. I generate a random number between 0 to 6, and that returns me 2. So what I do is I return 2. 2 is now assigned to the big URL, and I move 2 here, right? So 2 comes here. So 2 comes here, and 6 comes here. All right. So the new array now becomes this. Next one number again comes. So what I'll do is, now I'll decrease the size. Size is till this. So I'll generate a random number between 0 to 5. Let's suppose the number that came was 1. What I'll do, I'll move this 1 to this. I'll swap the two numbers. What will be the resultant array? The resultant array would be 5 will come here, 1 will go here, and size minus minus. If I have to generate new next random number, what I'll do? I'll take random of 0 to 5. Let's suppose 1 is generated. Now 5 and 4 will be exchanged, right? So the data will become 4 here, 5 here, size minus minus, and so on. I can just continue this. So using this way, I can, find out, generating a random number between two numbers is very easy, right? It's an O1 kind of an operation. So using this particular approach, I can find out keys, and I can ensure that the guessability factor is maintained to a certain extent. And how do I distribute if I have multiple? Let's suppose I just have 10 buckets each. So how do I distribute? 10 buckets means that one server, let's suppose, can handle only 10 keys. How do I distribute them? I have a list of 200 URLs that can be generated. I pick the first 10 and I send it back. I save this 10 in the first server. That is how I can ensure that each server has 10 keys to work with. All right, guys. Thank you so much, guys, for joining in. Bye-bye. All right, we are live. Hello, everyone. I am Mohit Yadav, and today we have with us Lokesh, who will be mock interviewing with us. The topic for today would be a topic around system design, and I let you introduce yourself and tell me something about yourself, Lokesh.
Hi everyone. My name is Lokesh. I'm currently working as senior software engineer at Akamai. So I'm totally having 6 years of experience. So prior to Akamai, I worked at Big Basket. So currently at Akamai, I'm working as full stack developer. So I'm graduated from IIIT Newsweed in 2015. So that's it about me.
Sure. Cool. So I'll just quickly tell the format for our viewers as well. I'll be asking questions. Lokesh will be answering me, and wherever I feel that I can, add some valuable feedback, I'll probably give that feedback to you, Lokesh, and to the wider audience as well. Right.
Sure.
Instead of giving the feedback and keeping the feedback for the last, I'll probably keep on giving the feedback as and when we go around. Right. Cool. So. I think there are a few users who have joined us. Let's wait for a couple of more minutes before we get started.
Meanwhile, I'll also share the screen. So whenever you talk about, if there's a need to draw something on a whiteboard, I'll use my iPad to draw that particular thing for you. For example,
Sure.
if you say the load balancer, I'll draw a load balancer for you. If you say something
Sure.
other things, maybe application servers or databases, I'll draw those databases as well for you. Right.
Sure.
Cool. So let's get started. The question for today is, you need to design a Google search type ahead. How would you go about designing that?
Okay, so basically, so if I look at the requirement, so basically, when users type something on UI, so he needs to get the list of suggestions. So in the drop down, so that's the basic requirement. And coming to the suggestions, so the first thing is the suggestions should be sorted by the popularity in the decreasing order. So the most popular should be at the top, or the most search or most popular.
Okay.
um, so and also sometimes, I mean, we also need to take care of the muted words. I mean, we don't want to show some pirated or some adult, so some kind of words we don't want to show, so we need to filter them. So that's also one requirement, so we need to filter them.
Okay.
So I'm just thinking, so popularity and so I think for, I mean, for this, so I'm assuming we need to display top 10 popular words, I mean popular phrases only.
So
um,
let's just say top 5 would do.
yeah, okay, fine, yeah,
Top
top
5.
5, yeah, top 5 words.
Right.
And so yeah, and also the most important thing is, it should handle the typos. So if we make any typos, the user make any typos, so it should handle that. So that is one word, I mean one requirement. Yeah, so I'm assuming this is the scope of this system, I mean,
Okay.
as per the functional requirements. um so and
Anything
so
else that you see in a typical Google search?
mm,
For example, if you search for weather and I search for weather, we'll be shown different results.
okay, you mean the informational results. So should we also
Right.
consider, is it like
Correct.
so? Okay, so that means, like, Prime Minister of India. So in the drop down, we'll get the answer for that. So you mean those
Not the answer.
information?
For example, if I type Prime, I watch prime time news a lot. So for me, the suggestion can be prime time. Let's suppose you search Prime Minister a lot.
Okay.
So for you, Prime Minister will come.
Okay. 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 Got it. So using the cookies, so user cookies or personalization. So user
Correct.
personalization recommendation. Yeah. So
Right.
personalization. Yeah, that is true. That I missed it. Yeah, that's one of the thing. And so also we should we consider the location based search or
Yes, we can.
not? Yeah.
We
So we
can.
can.
So this is basically the first phase, right? Where we just
Yeah.
scope out that just by looking at Google search type ahead, these are the 5 things or 10 things that are coming to my mind.
Yeah.
Now, in order to discuss it in a 45-minute interview, it is not possible to go and design each and every
Yeah.
feature. So we'll just
True.
limit the number of features that we are going to discuss. So I'll
True.
cross out popular. We definitely need to sort the result based on popularity. That's a must-have. We
Yeah.
don't have to filter words. We can assume that filtration is not required. So
Okay. Yeah.
this is something that we can remove.
Okay.
Top 5 again. Top 5 is a primary requirement for Google search, so we need to have that. Typo handling also we can ignore. Personalization and location based suggestions are also something that we can ignore for now. Right?
Okay.
We may discuss it if we have time towards the end, the
Exactly. Yeah.
personalization bit, right?
Yeah.
So let's start with these two, popularity and top 5.
Yeah. So these are the functional requirements, and coming to non-functional requirements. So basically, so the system that I want. So the first of all, I mean, if I go by cap, so the system should anyway have to handle the partition tolerance because of the network failures or any failure. So the partition should be always there.
Okay.
And then if I want to choose, that means, I mean, basically, the scalable. So I'm actually choosing scalability to be my first priority. And also, so over availability and consistency. So for this case, I actually go with availability. The reason being why I do not go with consistency is because, so I mean, like, eventual consistency is okay. So instead of strong consistency, eventual consistency is okay for this system. I'm thinking, why? Because I mean, sometimes I mean, even though if we are not, so let's say we have some top five results, but let's say I mean, we are showing, let's say the incorrect one. Like, in the, let's say, there is a term which is top five, but we are showing top six, or I mean, one, I mean, which is misplaced. So that is fine. Like, it can eventually propagate, and we can show. So that's why I'm actually going with availability and the scalability. So, and coming to scale estimations. I'm actually, so first of all, the number of requests. Basically, since it's a scale of Google, I'm thinking maybe some 5 billion requests per day at the scale of Google. I'm thinking.
So how did you come up with this particular number?
I mean, so basically, I just came with random, because so obviously, the request will be billions. I mean, taking Google search. So that's why I came with, like, some 5 or 10 billion. So 5 billion I came up with.
Okay, a good way for scale estimation, right? This is
Okay.
I'm basically giving you feedback. A good way to do scale estimation is to look at the daily active users, and
Yeah,
then
exactly.
deduce what are your TPS and storage requirements would be, right?
Yeah.
So Google has I think close to 2 or 3 billion. Let's for the sake of calculation, let's assume that Google have 1 billion users, and every user maybe queries at least once a day, uses
Yeah.
Google search at least once a
Yeah.
day. So there will be 1 billion queries uh, per day. These are the reads, and every read
Exactly.
is contributing to the write as well. So I'll leave
Exactly.
the thought here and let you continue the thought.
Exactly. Yeah. So this system is actually uh, read and write. I mean, so read and writes are equal here. So that means 1:1, and so that means, here it is one. So we are so thinking. I mean, we are having that 1 billion requests per day. I mean, because we are having 1 billion users. Coming to coming to the storage. So I think we can leave this here, and then coming to storage. In our system, so we only need to store the queries. I mean, the words or the queries. So for that, I'm thinking, so maybe, so each query each query at max may not store may not take more than, so maybe, like, since they're strings, so and they actually, I'm thinking, maybe, like, less than a kilobyte. So that means, like, something like um, some 512 bytes or something. I'm thinking, like, half a kilobyte. So each word. So that means we are having 1 billion requests. So 1 billion into half, I mean, into 0.5 kb. So which will, I think, I need to calculate. So
This will
something,
be something in terabytes, but is that
yeah.
calculation correct? Because although we are getting 1 billion search queries, do you want to relook at this number? Because all of them are not unique.
Yeah, exactly. So yeah, all of them are not unique, and so and in our system we don't write them. So we don't write all of them. So we already may have other info. So that's why I actually the maximum threshold. So let's say we got a word or we got a phrase in the worst case that is not in the system. So in that case we have to store the whole word. So that's why I came up with less than a kilobyte, so around maybe some 256 bytes or something.
Okay.
I mean 0. Yeah, so 256 bytes. So at maximum I'm thinking.
Okay. So we'll leave the storage part here. Let's move ahead. Let's just assume that one box is not enough to handle the entire storage data.
Exactly.
Okay.
Exactly.
Let's just assume that there were some issues with the storage. The issues were that you were reducing the size of the particular record. Instead, then what I'm arguing on is that you won't be having 1 billion records to write. Because let's say
Exactly.
I search for Michael and you also search for Michael, that will end up going in the same direction. I'll just upgrade the frequency. But let's
Exactly.
see the design first, and then we'll come back to the storage part later.
Yeah, sure. So I'll go with so the basic design. So basically when we so we can actually think of the first thing that comes to to our mind is try. So I mean, to store them in a try. So it's very very trivial and obvious that I mean, by looking at the question, so that means we have to use try. So basically we'll have one node, and for each node we'll store them. Yeah. Um so let me first try. I mean, let me first go by the flow. So basically the user sends a HTTP request, so with the votes in it. So let's say user searches with Donald.
Okay.
So as you written. So basically I mean, initially I'm assuming that I have only I mean, I don't have large scale, but small system. So basically so the client sends the request, and I actually go and look up the try. And each lookup I actually try to find. uh, I mean, if it's a successful match, that means if it's a successful vote, so then I actually update the frequency at the terminal node. So basically we know that in a try we actually store a boolean called is vote to tell whether that's a vote or not. So basically yeah, so that's a vote. So whenever it ends there, so in our case we also store the frequency, so which will be updated incrementally every time. uh, so and
So one quick
yeah.
question over here. So you said that let's suppose the search query is Dawn here, right? And there is a null character over here as well. That means Dawn is also a valid word. So you
Yeah.
suggested, let's say, two words, Dawn and Donald, and he clicked on Donald. So what all, where all? Now I think each node can have its own frequency.
Sorry,
Terminal
each
node,
node.
each node means
Yeah.
each terminal
Each
node
terminal.
can have its
Yeah.
own frequency. So
Yes.
which all frequency would you modify?
Yeah. So you're saying when user enters DO and Don, so we'll suggest Don and Donald. So
Right.
if user clicks on Donald, so which we will increment, right?
Correct.
Yeah. So in this case, since user selected Donald, so that means will increment the frequency of Donald. So that means the D terminal node, because I mean
Right.
that's where that is getting hit. So this frequency will hit. I
Correct.
mean, however, there are still problems with this, but we'll eventually find it out.
Right.
So this is the basic approach. Uh,
So what are the
so we,
problems with it in terms of,
yeah,
so what I want is top
exactly.
five. How would I like what is the complexity of your current solution basically?
Yeah, exactly. So so here the problem would be, so when I want top 5, so I actually have to traverse the whole tree.
Correct.
So that means, so let's say when I said like DON, so that means from N, so I need to actually traverse through I mean whatever the depth of that a tree, I mean located at N. So I need to look them, and then I need to find the maximum of them, and then again I to return them. So
Right.
here the problem would be drilling down the tree. So I mean we need to find, how can we resolve it.
Right. So
uh,
first of all, first question is how would you find top five out of, let's suppose you are doing the iteration also.
yeah.
How would you actually find the top five elements?
Okay, so you mean so
We can do iterations. This is as good
yeah
as I have an array and I
yeah,
need to find top five. So
exactly. So the main thing, and also basically when I so came across this top or I mean uh, kth largest of these, so I actually think of building heap, but again so I'm thinking, so I mean, so can we store this information in the in each node, like, so as we build the try, can we actually store, so let's say at N, can we actually store the information that, okay, so top five votes at N are these, can we
okay.
actually store them? I mean,
So
so yeah.
which data structure would you use to store that?
So here I'm thinking, it would be it would be enough if we can store the references of the terminal node. So let's say so N at N, so D is another terminal node having some good frequency.
Correct.
So here we can uh, see here we can use a heap, uh, a max heap.
Okay.
So a max heap.
Max
So
heap.
we can
Okay.
so the top
Are
will.
you sure that you'll use a max heap for finding top five?
So because here we need top by the decreasing, I mean by the decreasing order of the popularity, right? So that means every time I actually remove the maximum at the
Mm-hmm. I lost your voice actually. Hello. Yeah,
hello.
now it's now you're audible.
Yeah,
Uh,
am I audible?
yes, yes, you're audible.
Hello.
Yeah, hi. Hello,
Hello.
hello. I can hear you fine.
Hello.
Hello, hello. Uh, it's a recorded session. How can you say it's live? It's not a recorded session, Sahu. It's actually live. I can hear you, man. Lokesh, hi. Hello. Can you hear me? Uh, Facing technical challenges, guys. Just bear with us for some time. Can you try reconnecting, Lokesh? I'm able to hear you fine. Meanwhile, I'll just take questions that are there. So, locations-based personalized search, yes. Fast response time, yes. Hey, Lokesh, are
Hey.
you? Am I audible now?
Yes, yeah, I think some
Yes.
glitch, I mean, yeah, fine.
No issues. We are back. So we were discussing about that. You said we'll have a max heap over here,
Yeah.
right? So do you see a problem in that? I'll give you some numbers. Let's say these are the numbers: 4, 5, 3, 0, 6, 3, 6. All right. And let's suppose you want to find top 3 elements. So you try
Yeah.
building a heap. So you added 4 in the heap. Then you add
Yeah.
5. So 5 is added. Then you add 3. 3 is added. Now comes the value of 0. Should 0 be added or not? How do you decide that?
Okay.
Basically, you'll have to check
So,
all the elements in the heap to do that, right?
wait. So, okay, you're saying, so we want top three, right? So, okay. So yeah, in this case, we will check. Yeah. So basically, we need to check the minimum element to find, but the minimum is not at the, yeah, maximum is at there.
Yeah,
Okay. Okay. Yeah. Yeah. That's true. So if we find three, yeah, that's true.
that's true,
So,
right?
hmm.
Yeah.
So when it came six, so we'll check with three. If it is greater, then yeah.
Yeah. So instead of this, what we could have is a minimum heap,
Yeah.
a min heap basically. So 4 will be there, 5 will be there, then 3 will come. So 3 comes here and 4 comes here. Then
Yeah,
0,
we
0
can.
is not greater than 3, 6 is greater. So we'll remove 3 and we'll add 6. So that's how it will be done.
Yeah.
Cool. So every node will have a min heap attached to it. The size of the min heap will be 5.
Yeah.
Till that we have solved the problem. So using that we can typically answer our query in an order one time,
Yeah.
right?
Yeah.
So
Exactly. Hmm.
cool. So till that we are clear. What about what can we do after that?
Yeah. So this is the basic design. So I mean, like, I'm thinking about, what else. I mean, what other problems do we have with it? So I mean, when we scale this up, so the main problem would be the storage. So, like, how do we store, try, how do we handle such a huge use scale? So basically, so one thing we can do is we can actually replicate the try. I mean, we can actually use like master slave approach by having, multiple copies of tries. And then we can, we can propagate, like, just like how in databases. So we can write to master and then schedule to slaves. So that approach we can do. I'm thinking the problem would be, so the latency would be more in this case. Like,
Mhm.
uh, so I mean, writing to, so there can be replication lag, so we can add to the latency of the user. I mean, the consistency can be little compromised. So this is one approach. And also, one more thing is, so this is okay, like, so this is okay when we can store the try in a one machine. But what about, if we have to partition that, so that also we need to consider. So what
So
if it
let's
exceeds?
break it down. What are the problems with this particular approach? Let's write down all the problems and then we'll discuss
Yeah.
one by one what can be the
Yeah.
probable solution. So what are the problems? Can you identify the problems and tell me what those are?
Yeah, the first problem is, so I would say, the data partitioning.
Uh, okay. So I'd say storage,
Yeah.
right? What else?
Yeah,
That
storage.
entire data, the entire try that we are building cannot fit into one machine because we are storing the search, like we're storing the try of all the searches, right? So that is one problem. What is the other problem?
Yeah, so that is one problem. And should I also consider on the client side, like what issues we'll have on client or not?
Not the client side. We are designing the backend, so let's focus our
Oh,
discussion
only
on
on
the.
the back. Okay. So, and also caching. So I mean, should we have to cache some queries or something? I mean, should we implement
Okay.
caching here?
So what kind of
Uh,
caching are we uh, doing here? This is
uh,
a try, right? So try would be stored in memory, so we don't require a cache.
So I mean, like, so I mean, if there are some popular things, so we can actually return. I mean, we can actually store some entries in cache, and we can write it to try asynchronously. I mean, to increase latency, because I mean, the main requirement of the system is to have low latency to the user,
Mhm.
because if you I mean as the users are typing, it should come in milliseconds. So I mean, what if we store the like popular ones on cache, and then we update them in the asynchronously to the try.
If you say, how would you identify the popular ones in that case? Is basically what you're saying is that maybe for some queries you'll save data somewhere, so that those are anyways the top 10 or top 100 or top 200 or maybe top 1000 queries. You'll store it separately, and whenever the term comes, you'll give the response from there. But let's focus on the main problem. The main problem is that we need to give a consistent
Okay.
response for every system, right? We don't have to optimizing for some queries. We can do it later, but let's
Okay.
optimize for the larger set of problems. So, apart
Okay.
from
Okay.
storage, do you see any other issue in this particular approach?
Yeah, I'm thinking. So storage and so we so I mean, so main thing we need to improve is latency. So that's the main important thing so in this system. So for improving latency, I'm just thinking, so what else we can do?
So we identified. Uh, do you think updating these top five, when we are updating the
Yeah,
frequency of a Donald,
yeah, that's
the
true.
we
Yeah.
need to update
Hmm.
D, L, all the nodes, right?
Exactly, I'm coming there. So so when we are updating the updating one terminal node, so
Right.
we need to traverse back I mean, so many levels to find each terminal node and so on to till root, maybe
Mhm.
to our I mean sometimes, and we need to update this top way. So these updations are yeah, I mean, are so here that's one problem.
So you said we need to update terminal nodes. I think we need to update every node that's there in the path till the top node. Why? Because even if a person has typed DO, there should be a heap
Yeah.
corresponding to
Yeah,
O,
that's true.
which can give
That's
you
true.
the node reference, right?
That's true. That's true. Yeah, yeah,
So
that
we'll
is true.
end up updating L, A, N, O, and right up to D. So for
Yeah.
one read, I am actually doing multiple write operations.
Hmm. Yeah, that's true. I mean,
And
so these.
while
Yeah.
I'm updating this, do you think read can succeed?
So 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 you mean, like, so we will not so we'll not update them in sync way, but we'll do it in async way. So we'll just return the result, and we'll so use asynchronous way to update those nodes. But that still be a problem, because updating those I mean, so considering the scale, the number of requests, so the updations will be a lot.
Mhm. So, basic thing, right? Let's suppose I have one database where this is a chunk of database. I have a value of x equal to, let's say, 5,
Yeah.
right? Uh, People can come and read the value of x equal to 5. There can be multiple
Yes.
read threads that can come and read this particular value. Now, let's suppose
Exactly.
there is one thread which is trying to update this value. It wants to set the value of x equal to 10.
Yeah.
Unless this value is written, all the read threads will have to wait. They cannot read this value
Yeah,
of
that's true.
x. That's true. So if I have to
Yeah.
update the value of all the nodes, till the time I will not be able to serve the reads as well?
Yeah, right. Yeah, that's true. That's true. Yeah, I mean, so in that case, yeah, reads has to wait till these are harm. That is true. Yeah. So
So my problem is how to make this a read intensive. It's
read.
a read equal to
Yeah.
W kind of a system. I want reads should
Yeah.
be greater than W, much greater than W. What is a way to do that?
Okay. So to optimize reads, how can we? Okay. So question is like to optimize reads. So I mean, how can we optimize reads? So I mean, when we
Yes,
have more reads,
yes.
um,
Can I mold my system in such a way? Can I have some kind of a design trade-off added here, which will make my system more read friendly, and I will do writes only after. Like I need my writes to be very less as compared to the reads.
so how can I mean? What if we have? I mean, instead of storing a big try, so you know what if we have? I mean, because when we are writing in a big try, one made in one try. So what if we?
Mhm.
I mean, if we chunk it and store the chunks and based on the ranges, if we go to that particular try and only update that try, so that we are reducing the blast radius, right? So we are just reducing it. So
So
I'm hmm.
not sure how that would impact the number of writes. So right now, what we are doing, I'll give you a hint. Right, right now, what we are doing is whenever a person clicks on chooses one suggestion, we are updating that particular frequency over here.
Exactly.
Do you think that it makes sense to update the frequency every time a user clicks on a suggestion? By the way, guys who are
Um.
looking for what
Okay.
the question is we are designing a search type ahead. Yeah.
Okay. Yeah. So I mean, if we do not update, so then the subsequent reach will not get the top. So I mean, so uh, so when we are reading, so you're saying instead of updating, maybe we will update later, or in I mean in some intervals we'll update. Uh, I mean we'll just store them and then update in regular intervals. Maybe
Yes. Yes.
saying.
How? Yes, that you're going in the right direction. Where can we store it? How can we store that?
So basically, so whenever user clicks on that, so we are actually updating. Instead of that, we'll store them in some message queues or something. So then in some message queues, and then we will actually have consumers that consumes maybe every hour or some regular intervals to update them.
So even that, when you're storing in a queue, that also has a problem, right? Some consumer will read that message and then come to update this particular try that we have, right? Instead of that, why not store it in a hash map? Can you use a hash map to store it somehow, and then after some frequency or after some threshold, you update the complete frequency?
Yeah, but so you're saying with message queues will have some redundancy, is it?
No, so for message queue, let's suppose I store it in a message queue. There
Mm-hmm.
is a Donald message here. There is a Donald
Yeah.
message here. There is a Donald message here. So I'll end up, whoever is consuming my message will end up updating the
Yeah.
queue the same number of times you have pushed the message. So my
Yeah,
rights,
that
I'm
is
not
true.
decreasing the rights.
Yeah, that
Can
is
we
true.
use,
That is true.
make
That is
use
true.
of a hash map and decrease the frequency of writes?
Yeah. So in this case, we'll have a map that will have the that will have the frequency of each word
Yes.
in that regular interval, and then yeah, we will update in one shot. So one
Correct.
I mean one shot we can update. Yeah.
That's true.
That is,
So
yeah, that is,
our
yeah,
criteria could be that we only update once my frequency reaches beyond 1000. And 1000 for a billion, if I consider billion search
yeah,
queries, 1000
yeah,
is a very, very small number, right?
yeah,
So I
true.
can afford to have a error margin of 1000. I don't need to,
Yeah,
it need not be a very accurate margin as well,
yeah,
right? So
true.
just keep updating the frequency in a hash map, and once you reach, let's say 1000, you update for that particular keyword. So for Donald, you'll just iterate through the tie and update the frequencies
Yeah,
plus
exactly.
1000 to whatever it was earlier,
Yeah,
right?
exactly.
Cool. So my one problem is solved about the write part. Now my reads are more, so I can add more parallelization. I can have I'll basically have lesser number of writes. So that
Yeah,
inherently gives me an opportunity to cache or do all sorts of optimization.
yeah,
But we still have this problem of storage. That entire
storage.
try, I cannot push the entire try in a single box.
Yeah, yeah, that is
So
true.
how do
So
I
yeah,
get rid of it?
yeah, so like we can actually partition it in such a way that maybe I mean, I'm just iterating some possibilities and we can actually look at the pros and cons. So one is
Sure.
so range based partition, like all A's or all B's at once. But this will not scale well. Why? Because let's say the votes at with starting with X or W maybe less than the votes starting with other alphabet. So again, so that will be a problem. So or we can actually take prefixes and store by prefixes. uh,
Okay.
so maybe like so A to like from like AB to AD or something, so those prefixes if we store.
A to, let's say, K is something, L to M is something, and X to Z, something like this, right? Maybe
Yeah.
basically bucketing. You're basically creating the buckets.
No, I mean not like that, but still, not with length of one, but maybe three. So let's say, so there can be words like so like starting with cat. So and again, there can be many words. Maybe let's say some millions of words, and if so like taking that prefix and storing by those prefixes like so AB or ABC and so on.
So
Um,
I think AB is stored in one, and then AC is another one, AD is another one, and so on.
yeah.
Okay.
So
So
yeah,
let's suppose with this I'll have 26 into 26 characters. These many
machines. Yeah.
combinations I'll have, and it is not really necessary that I might have more machines. I might have lesser machines,
Yeah, that is
right?
also true.
So how
Yeah.
would you
Huh.
map this number with the number of machines that I have? Let's say I have
So,
n number of machines. So how would you map this? Uh, let's call this x number or x number of prefixes with the n machines that I have.
so we can actually do by hashing. So, for a word, we can have a hash function.
Mhm.
So that can actually, I mean, so when we store, so basically we'll not store all those ABs in one machine, but so basically what I'm saying, so let's say we'll determine so words starting with prefix AB or AC, AD, and so on. Some K number of prefixes will store in one machine. So I mean, like that will store in multiple machines.
Mhm. So
Uh,
the question over there is, I think what you're hinting at is that there'll be out of these, one machine will hold multiple prefixes as well.
yeah,
But how would you decide? Let's suppose I have prefix AA. On which machine this particular prefix should go? How would you
yeah.
determine that?
So basically, so these machines will be behind a load balancer. So where my load balancer will maintain this mapping. So this with that mapping, the load balancer can redirect to that particular machine.
Okay, so basically there is a load balancer which is sending it to one of the machines that is available,
Yeah.
right?
Yeah.
But in the load balancer also, most of the load balancers are primarily stateless. So
Stateless. Yeah.
you need to have a stateful kind of a load balancer over here. So do you
Yeah.
know how to do a load balancing in stateful system? I'm just looking for one specific term. Anand Kumar R, you are right. You've used the right term. So basically, the term that I was looking at is consistent hashing, right?
Yeah. I mean, I was coming to that. I mean, as I said,
Right.
hashing there. So I
Right.
mean,
So
I'll actually eventually come, but this I got it. Got in my mind. Like, yeah. So consistent hashing we can do.
right. So we will use consistent hashing. You've still not answered what would be the shard key on what particular parameter. I think this is your shard key, right? AB and AA and EC. That is what your shard key. But what will you call that? Again, looking for a specific term. You've answered that in your previously.
Okay. So I mean, you're saying these prefixes. What do we call
Yes, prefixes.
them?
Prefixes is what I was looking at. So prefix becomes my shard key,
Yeah.
right? And once I have these prefixes ready, I can just push it to a consistent hashing ring,
Yeah.
and it will distribute the load evenly, and it will take care of how many number of servers are there, how many number of servers are not there. So we have
Yeah.
correctly solved the storage problem as well.
Yeah.
Any other problems that you see?
Mm. So I mean, can you go up? So I mean, the scope is only top and I mean, I
Yeah,
forgot the scope. So only top
top 5 and
and
popularity.
popularity. Okay. So popularity problem is solved and top is also solved.
Right.
So and we'll do optimization. So I mean, like as of now, I don't think so much problems here. So I mean, because the basic design is fine, like we can apply optimizations on these.
So we have introduced sharding. What if, let's suppose this particular application server is holding AA, BA, CA, and some more data. What if this server goes down?
Yeah.
So how would you ensure that if this server also, if a server goes down, then also your system is run?
So I need to copy. I mean, I need to have these keys in another system. So that's
Correct.
one. I mean, right. So um,
How do we do that?
1 minute. So I forgot that. So
This is nothing but replication, right?
yeah. I mean, so
This is replication.
so that means we'll keep the replicas in other machines also, right?
Yes.
Or each one. I mean,
Yes.
each
So
of the prefix. So go.
each of the prefix can be replicated to multiple servers as well,
Multiple servers. Yeah,
right?
that's what.
So
Yeah, I mean,
and that is how we can define how we are basically replicating. So I'll quickly ask you a question on consistent hashing itself, right? So let's suppose these are my server IDs 1, 2, and 3. All right.
yeah.
Now let's suppose I have one object over here.
Hmm.
Okay, this is key 1. I'll use a different color. This is key 1. Okay. Now this K1, on which server will this data will be stored for K1? Either you go in the clockwise direction or you go in
Clockwise
the
or on anti-clock? Yeah,
or anti-clockwise. So let's choose one convention. Let's go in the clockwise direction and let's store
clockwise.
it
Yeah,
in 2.
2.
So 2 is holding my data.
Yeah.
What is the next server? If let's suppose I set the replication factor equal to 2, that means 2 server needs to hold the data.
Yeah.
What would be the next choice of server? Should I push this data to 1? Should I push this data to 4? Should I push this data to 3? 2 is the ideal candidate. I have added the data, but I need one more server to hold a copy of this particular data. Which server out of the other 3 available is the best candidate for that?
Okay. Okay. So,
Your options are 1, 4, and 3. 2 is already holding the data.
okay. So now 2 is holding. So if we assign to 3, so the problem would be, so if we assign to 3, the problem would be, since we are going in clockwise, so if 2 is also went down, for 2, we again have to store them, store the replica of 2 in some other machine. But storing in the clockwise would be a problem here, because if 2 goes down, so we will we'll have 3 for it. Wait, I'm not able to.
So you're going in the right direction. So where will this K1 be routed if 2 goes down?
So it will be routed to 3. So so in the
Right.
clockwise, it will be routed to 3.
Correct.
So that means if we store at 3, so if 3 also goes down,
Then it's a different problem.
yeah. So that's a different
We'll
problem.
solve one
But
problem at a time.
yeah.
Right
Yeah, I
now,
think
if 2 goes down, there should be, we don't need to
3.
transfer the data from 2 to some other node. My newer queries will be routed to 3, and 3 already has the data.
Yeah.
Right. So
Yeah.
my natural choice becomes 3 in this case, right?
Exactly.
Right. Cool. So yeah, I think that is we've discussed enough on this. There is one more way to decrease the number of write operations. Can anyone, you or anyone who's joined us, tell me one approach which we can use to make this property hold true? Right now, if I don't do anything, writes and reads are same. I want a system where my reads are much greater than my number of writes. One way that we have discussed is the hashing approach. Can you guys think of one more way to do
So
this?
as you said, hash map, so similar to that, maybe map reduce kind of thing we can use. Like we'll have a map, and then those reduced jobs will write it down to them.
What is your mapper step here?
So whatever. Okay, so in this case, so the mappers will be. So maybe if we can store the words and map them into. Into an object, like similar to hash map. So how we map them, so we can transform them into the number of occurrences or number of the frequency, and then pass it to reducer.
Okay. And I still don't understand how. Let's suppose this is a Donald, again using the same, abusing the Donald name. But let's suppose this is a term.
Yeah.
What would be the mapper step over here? What operation am I doing here?
Yeah, so I think here this is not possible. Why? Because we'll have multiple objects. So so the map step is applied only. The transformation can only be applied on one particular object. Like we cannot combine with other. I'm assuming. So that's what I. Yeah. No, I think
So,
that's not a good solution.
I'll take options that people are typing in the comments as well. So Jalkrit is saying, Jagkrit, sorry, is saying that we can use a NoSQL DB as well. So any time you appear for a system design interview, you should refrain from saying terms like NoSQL. I'll use a NoSQL DB, and that will solve the problem for me. Why? See, Google search type head problem can be solved using Elasticsearch, right? It gives everything that I want out of the box. The aim for a system design interview is to judge whether you, if I give you a new problem, can you design it on your own? And then if you answer if your answer to a particular question is that I'll use a NoSQL DB, my question would be which DB would you use, and then I'll dissect whether you know the architecture, how that particular DB is designed or not. So unless you don't know how the architecture, how the DB is architected, do not use these terms in the interview. These are a red flag when you know use a random technology and don't know what is the architectural decisions behind that particular technology. Try to stick to the basics. If you're using caching, don't say Redis. Say I'll use a cache. And when you're saying you use a cache, it should be clear in your mind that hey, this is going to be my key. This is going to be my value, and my retrieve. This is going to be my retrieval pattern, right? That is very much essential during an interview. So keep that in mind. Yeah. Sorry. Over to you.
Yeah, I mean, so yeah, I cannot think of it.
Anyone who's done machine learning, they would,
Okay.
I think, be able to get a better hang of it. It's a simple statistical tool, typically used in not just machine learning. Machine learning is one area, but it's a purely statistical way of doing things.
So someone said
Arpit says
Bayesian.
Bayesian. Okay, Bayesian. Not really. But what you can typically do is use sampling.
Okay.
The idea of sampling is that if it is popular, don't use average or anything like that. Just use sampling. If it is popular, right, there most of the chances, if you just skip 99 requests and choose the 100th request, it will be the request of the most popular one. For example, if it's a India versus New Zealand final that is going on right now, if I search for IND and missed out, just randomly choose the 100th request, it will be for India versus New Zealand. And because I have that kind of scale, I can just remove or let go of the 99% of my request and just choose one request that is coming to me. Of course, there will be some error threshold over here. It will not be accurate, but it will be a very much close to accurate guess, I would say. So sampling is one more thing that you can typically do. I only consider the 99th or maybe the 100th request. 99 request, I'll just I won't just care about it. And in fact, this sampling way is used in many applications, right? What I was saying is, so I'll just summarize what I just said, right? What I just said was that if something is very popular, like for example, if I type IND, IA will automatically be suggested because India has been searched by many people, right? If it is, if there is something else that is coming out of IND as a prefix, it will be searched by many other people as well. And by the law of averages or by the law of randomness, what I can surely say is that even if I remove the 99 first 99 requests, whatever is the 100th request, that will the probability of getting that particular number which is popular, that is really high for a actually popular request. I'll give you a small example. I'll write as let's suppose I have 4 spaces, 1, 2, 3 and 4. All right, what is the probability of picking 1? It's 1 by 4, 25, and so is the case with every other number that is there in the array. Now let's make some more interesting. Now what I've done is I've added one more 1. Now if I ask you to pick a number randomly, there are 50% chances that I'll end up choosing 1. Now let's remove 1, add one more 1 in the 4 numbers. The percentage now shoots to 75% chances of getting 1. Right? And this is the law of popularity. Out of the 4 numbers that I had, 1 is really popular because it is occurring 3 times. If I choose a number randomly out of this particular batch, I have 75% chances that I'll get 1. For truly popular systems, the occurrence of this 1 is over 99%, right? And that is what I was hinting at. You just sample your request, create a sample of, let's say, 100 batch. Out of that batch, pick one element randomly, and the chances are that you will end up picking up the most frequent or most frequently searched phrase. So this is a small idea about sampling that you can go back and apply in other systems as well. Yeah, I hope this leaves you with a food for thought. Yeah, cool. Anything else that you want to add, Lokesh, on the problem that we have discussed?
So on backend, yeah, I think that's it. So I mean, just one thing is that maybe on clients we need to add throttling, that so like as we are typing, so like we said, debouncing. So there's term called debouncing. So I mean, that means, let's say if I type a and there's an interval, like some 600 milliseconds, like that. So if I stop typing, then I should send a request. If I'm not stop typing, so I should not send the request. So that debouncing maybe we'll add on clients. So
Right.
to optimize, yeah, I think that's it from my side.
I think your voice is cracking. I don't know if if that's just me or is
So
it cracking?
is it is it fine
It's
now?
better now.
Is it fine?
Yes.
I mean, some
Yes,
maybe.
Yes, that's better.
Yeah.
All right. Cool. So we've discussed a problem, a system design problem with everyone, right? And I think we are quite done with the 1 hour mark that are typically, added, given for a system design interview as well. I'll give you, before leaving, I'll give you guys a thought about what are the typical challenges that people face during system design interviews, right? Pacing yourself is quite important, right? I think the pace that you showed, Lokesh, was spot on. We were able to cover quite a lot of ground in 45 minutes. We didn't touch upon many factors as well. I didn't go deep into understanding the how would you implement a try and all that. But I think that is not an objective of a objective as well, right? We didn't go into things like rate limiting and things like how would you actually persist a try on DB, right? Everything
Yeah.
was there in memory, so we didn't go into how would you persist a particular try, so that
Yeah.
in case the server restarts, how would you handle that? We've not discussed. So we've not discussed the length of a particular prefix that you will add. So would you add a also as a prefix into the consistent hashing ring, or would you require a minimum length? If you're having a
Yeah.
minimum, like what are the pros and cons of all those things? That is something that we've not discussed. But I think within a given the time frame, this is a decent enough discussion. There are multiple other aspects as well that we can look at. For example, personalization. Typically, if you are interviewing for a senior role, you would be asked to go into one peripheral area. I didn't get a time to dig deeper into the other peripheral features that we had missed out. The other peripheral features are primarily there to test whether your approach or the solution that you're giving is extensible or not. Right? For example, if on this particular system also you want to add personalization, how would you change or tweak your
Yeah.
system? Do you
Yeah.
require to change the entire logic? If that is the case, then your system is not extensible. And extensibility is a major component when it comes to testing out things, right? So I'll probably jump to questions that are there in the comments, right? If you have other prior engagements, I think I had blocked only 1 hour of your time, Lokesh. If you have any prior other engagements, feel free to drop off. I'll take the questions and then I'll wind up. Do you want to stay or
Sure.
do
Sure.
you want to?
So I want to drop off because my mom is waiting for dinner. So yeah,
Sure,
I'll
sure.
drop off, guys.
All right. Thank you so
Okay,
much
guys.
for your time,
Thanks.
Lokesh. Have a nice day. Bye bye.
Yeah. Thanks. Yeah. Bye, guys. Thanks.
All right, guys. So I'll take up all the questions that might be there in this particular chat window. If you've still not typed your question, please do so. If you want me to interview you on do a mock interview for you as well, please mail us your resume at youtube@scalar.com. I'll just type it down so that it's visible for everyone. This is the ID that you should typically be looking at. All right, let's now go to the questions. Bhagya says fast response. Okay, these are the answers. Where are they? Are they in question? Should we handle location, current issues, and frequency, at least in count? What's the profile of the interviewee? I think Jai Kirat, we told like in the beginning we started off with the profile of the candidate. He was having 6 years of experience, an SD2 at Akamai, and prior to this he was working with Book My Show. I hope this answers your question. So Jayant has a question. In yesterday's short URL, why we use user ID for the table if you're searching for shortcode in the whole DB and providing the actual URL won't be time consuming. How about using a key value pair? One that was so the schema that I wrote that was primarily for a system with a very less amount of which is basically designed for very less users, not for a massive scale. A KV, a minimalistic KV is the one that will work the best for a URL shortener kind of a design. So try can be partitioned based on location. That is not a good approach, I would say, Arpit. The reason being because if you break down the try on a location basis, that will be adding personalization. But what we were designing today was basically a search type head that is globally accessed, and the frequencies were also changing globally. The prefix approach that we discussed at the end is basically the correct approach. Arpit says you should not block reads. How does it matter if the value goes a little here and there? Exactly. I think what he's referring to is that when we are writing a particular system, that is when we should never, whenever we update a particular frequency of a particular record, that is when we have to basically block all the reads, because the write will take a lock on the particular record, and hence reads will not happen. So we should avoid it at all cost. We have discussed two approaches to avoid that. One is hashing and the other one is sampling. So we can use either of the two approaches to uh, basically block down the reads and write value. So I see there are many people who have told that caching is the best way to do this particular thing. However, I would like to differ from them. Caching for a search type ahead is not a very good idea, right? We are actually caching quite a lot of things in the node, where we just traverse to the node and we're finding the output. We need to understand that caching by itself is not a solution to reduce the latency. For example, if I maintain a hash map in memory, that is much more faster as compared to storing the data in Redis. So whenever you are appearing for interviews and giving your answers that I'll use caching, have, instead of using caching word, or instead of using this, tell them where are you going to cache it. Are you going to have a distributed cache? Are you going to cache it on the client side? Or are you going to use maybe or maybe at a load balancer, or maybe at a global cache or a DB cache? Specify what kind of caching you are going to do and what is going to be the key. Here in this case, I am not sure what can be the typical key of key for a particular cache. How many prefixes can you typically cache also, and the frequency also. What if, let's suppose I cache, I'm taking the same example, Donald. If I cache Don and save the top 5 words, how would you update the top 5 frequency? That will become a problem, right? So I hope everyone who is actually attending the session understand that caching here is not the best way to go ahead. So Vishnu says NoSQL is a good option. I think I have spent some time describing that. Don't directly jump to a NoSQL database. Identify what are the requirements that you would need to design such kind of a system, and then discuss the trade-offs. Directly jumping to a NoSQL is a red flag, especially if you are interviewing for a higher profile. For SD2, it will still be okay. But for SD3, it is a definite red flag. Is it's memory already in memory? What will you cache? What does it mean exactly, Arpit? That is what I was hinting at. What would be the criteria for caching? I think Arpit, I've answered that. We will shard based on the prefixes. Okay. So Vineet is asking what we need to be prepared before giving an interview with you. In this particular mock interview, I had basically told Lokesh that, hey, I'll be asking you to design a Google search type ad. So the question was given to him already before he came for a mock interview. So whenever I take an mock interview with you, I'll probably give you a heads up that I'll be asking these questions. The sole purpose of giving the topic beforehand is we want to have a meaningful discussion while on a mock session. In an actual interview, of course, you will not be knowing the topic, so it's important to understand the system design concepts and prepare based on that. So typically, if you want to do a mock interview with me, I can give you a topic and we can have a mock interview on that, right? Any such stream for low level design? So this system design interview is a superset of the low level design, right? It's based on two important parallels. One is the low level design. For a system design interview, you need to design the schema. Schema designing comes under a part of low level design. as an interviewer might ask you to write some classes and code for that particular business logic that I'm asking you to implement. If you are a more experienced candidate, I might spend more time in discussing about the systems. Right. If you have lesser experience, I might ask you to design the classes. For example, the same question: how would you go about designing chess? Uh, I would ask this question differently to a person who's has maybe a college fresher, or maybe have 2 years experience, and maybe with a person of 10 years experience. For a person with 10 years of experience, I will drill deep into how would ensure make this particular chess game into a multiplayer game, or maybe not a multiplayer game, basically a two-player game, two-player online game. How would he bake in artificial intelligence? How would he make sure that there is no there's no cheating component that is happening in the chess tournament? So, uh, doing uh, focusing more on the system design aspects of it for a 10 years experience. For a lesser experience, I'll probably spend time in how would you design the queen class, how would you design the pawn class, how would one extend to the other, and how would you abstract out the common functionalities. That is what I'll test probably for with a 2-year experience candidate. I've learned from. Thank you so much. I hope I take it as a compliment. Uh, in memory, hash map is not scalable, can be used by a distributed server. So you can have a Redis cache as well, in case you want to have, in case you are limited by the number of, or limited by the memory that your application servers are having. You can typically take this component out in a different system itself, right? So that would not be a problem. Is it possible to explain try implementation at DB level in your upcoming YouTube masterclass? Unfortunately, YouTube masterclass will not use any concept of try. What we can, however, do is there are people like we also take masterclasses on data structures. We can pick this topic up in one of the data structure masterclasses, not at a system design masterclass, right? And DBs, as far as I know, there are no DBs which will allow you to persist or try. Right? You have to store it as an object and retrieve that as an object. For R much greater than W, keep cache on servers and have some hybrid approach for write through and write back policies to update the data back. Yes, Pratik, we can do that, but understand that tries are also stored in memory. So by storing, by having a separate cache layer, you are not actually gaining anything out of it. The amount of time you will spend on reading from a try will be closely similar to what you will to the performance that you'll get out of the cache as well, because essentially both of the systems are reading data from memory to find out the top key elements for a particular prefix. The max you have to go for is maybe 3 or 4 characters, or maybe 5 characters max, and you'll get the complete string. So you are actually not going traversing a lot of data when it comes to having the reading it from the try. Redis is a event driven system and not necessarily slow need. Okay, he's answering to Anand. What is the question of Anand? Okay, Redis is single threaded in nature. It can slow down the entire system. So Redis, even though it is a single threaded, it can serve the kind of latencies that you can get out of Redis server is around 1 to 2 or maybe sub 5 millisecond kind of latencies. So in 1 second, you can typically serve from a single thread itself. You can serve around 500, 200 seconds, and then there will be thread multiplexing can also happen. So sorry, you can have a multi-threaded application interacting with this particular thread. So that also will give your system a huge boost. So using context switching and all that, I have had instances where I can, with a single Redis server, I can serve million QPS. So Redis is blazingly fast, even though it is a single threaded application. Redis is an event-driven system and not necessarily slow Node.js, but very fast. CPU intensive. So Arpit says Redis is event-driven system and not necessarily slow. Is drawing parallelism from a Node.js server. CPU intensive application do require multiple threaded system, but not which are just network IO intensive. Agreed on this. Most of the time is spent on IO thread. So exactly. So not thread contention. I forgot the term for that. Yeah, context switching. So context switching will there'll be multiple threads which will be reading the data, and using threads will switch the context to give chances to other thread which is waiting for the waiting to be get into running state. Sharding, please. I think Bhavan, what you're asking is, are you asking me to explain what sharding means? I'll be uploading one video on sharding on under the system design series. So please stay tuned. Right. So if you're interested in knowing any other system design concept or topic, please feel free to comment on this video. I'll end this video now. But tomorrow, I'm going to tell you about how to answer the coding experiences. Like how do I answer coding questions, DSA questions in an interview. I'll probably invite one more speaker who will tell. So. I'll basically invite one more speaker who is also done taken multiple coding interviews, have himself cleared multiple company coding interviews at multiple different companies, at farm companies as well. So tomorrow will primarily be focused upon how do you appear for and how do you think about a approach when you're going for these coding interviews. And day after tomorrow, I'll take one mock coding interview, similar to in a similar format that we have done today, right? So I'll see you guys tomorrow. I'll leave leave the class now. Hopefully that made sense for you. Please subscribe if you have not subscribed to our channel. Right? I'll see you guys tomorrow.